Right, ladies and gentlemen, welcome to late night philosophy event or something. I have started this because I felt just a moment ago that there weren't enough bad ideas extant in the universe, so I thought I would instantiate another one, and that is this hangout now in progress. And I think I have someone with me. Is that Mr. Rotz? Is this you?
Yep. Let me get a glass of water first, though.
No. Get a glass of wine. Oh, let's see. I have a blockage. Good. There we are. Let us... Now, Mr. Johann Ratz is a well-known and occasionally publicly ridiculed Platonist. I worked a 12-hour shift today and then came home and had a few beers, and I'm going to have a couple more while I discuss whatever happens. So this is a late-night philosophy workout. For those of you who think you can't think deep thoughts after a long, hard day or a few beers, I'm proving all of you wrong right now. Of course, we will have to see whether the thoughts are deep. Now, if you want to join, you can go on to Facebook and look me up, and the link is there. This is public. This is for anybody who wants to join. Also, if you can see the comments in the side, if you're in Google, if you're viewing this in Google Hangouts, you can join clicking that link. And I can't view it on YouTube, or I would go put the link on YouTube and can't view it while I'm looking. It would create a small black hole in the universe. Mr. Ratz, you have a problem.
Oh, not you. Someone I'm arguing with.
No, you.
Left-wing social justice warrior.
Oh, what are they saying? What do they got?
Oh, he's trying to, they're trying to impose on private schools, basically. So,
Oh, they want to, oh, okay, yes, I've heard about this controversy. Yeah, well, they're doing some pretty handy stuff in California. They're also making it illegal to turn down vaccinations.
True, but this is the particular bill that is.
Now, what are they doing with the? How are they trying to shut down?
Shut down certain, they're going to cripple them, basically. It's you know, some schools have religious schools will have exceptions to providing housing for same-sex couples because they have moral objections to that.
Yeah, so it's private religious schools they're picking up.
Right. And they want to, the state wants to come and kind of force them to go by the official social justice agenda or be basically economically crippled.
Right. Now, this could either be step one of a defense against Islam or step one of the initiation of Islam, or Islam might have nothing to do with it, but I doubt
nothing to do with it particularly.
You don't think so?
I mean, it's I don't know of any, Islamic schools, like colleges in California.
I wonder if they're not going to be, well, come on, San Bernardino is a bit, well, hello. You've got Muslims. You've got 1 million Muslims.
Right, well, for example, they're actually targeting Biola, which is my own school.
They're targeting what?
Biola, which is my own school, as one of the schools.
What are they trying to stop you from having female only? You know, they're going to black only dorms and stuff now. Why can't religious schools have female only dorms? BYU does.
I don't have a problem with any of that. I mean, that's okay, but I'm saying is that they don't want that. They're trying to impose on specific.
No, I'm saying what's their argument why they can't? They're just come with egalitarianism and say everything's got to be the same. You know what egalitarianism is?
Yeah, I know. It's equalism, blind equalism.
Yeah.
Everything being equal, no respect for distinctions, and then furthermore, it's gotten to the point where they're trying to push it into the private sphere and saying, if you don't agree with our social justice agenda, with your own private stuff, then we don't have the right to come in and screw you up.
Well, what are they going to do when there are other schools who have black-only dorms? Native American-only dorms?
I don't know.
They're going to say that's okay because it's not a religion?
Maybe. I don't know. I haven't been familiar with that yet, and I've not actually heard of Native American only or black only dorms.
Well, I'm worried. I don't know what to do about it, but
It's social justice. It's a huge parasitic problem.
yeah, you know, I think it is really serious, but I don't think it's that serious here in America. I think we're just screwing around here. Look at Brexit. What do we have to parallel Brexit in America? What are we doing in America that has anything to parallel Brexit? We're going to build a wall with Mexico because they keep coming here to work in our restaurants?
I don't know. Hold on, sir. I'm arguing with this asshole. Sorry, pardon my French.
Oh, no problem. I speak worse French than that sometimes. Anyways, ladies and gentlemen, if you want to join me, you can go on Facebook, look me up, and click on the link and join us. So I was talking earlier about Brexit. The fact that they got out probably is going to be frittered away, right? They're going to destroy it. The bureaucrats are going to take the next 2 years, take advantage of the next 2 years to turn it into a bargaining chip for a better deal with the EU or something like that, and otherwise tie the UK up in all kinds of inappropriate stuff, and it's going to be frittered away. Also, there is the possibility that the government will ignore it. There's a lot of, obviously, they're talking about that already. Oh, it was 2%.
You want to talk about physics, and I agree with this whole social justice.
Listen,
I can't stand these leftists.
well, you've got this problem with physics, is you think that there's somebody watching us.
Well, that is going to come in handy, I suppose. I mean, I actually have a video planned on the implications for the afterlife and near-death experiences and so on. Actually, I have studies on this, like a whole journal studying near-death experiences, and I have a video plan on the whole implications of this on them. And so it is to enforce the notion of cosmic justice on them.
Well, no. Listen. This discussion will hereby be limited to reality.
Okay.
There's no. What do you want me to talk about? Oh, I have this unicorn with a really, really pretty mane. Purple. It's purple. A purple unicorn. No, the mane is
not
purple.
Part of the anti-structural realism.
No, the unicorn's really pretty. Pink. The unicorn was pink. The mane was purple.
Okay, the mane was purple, and did it shit rainbow poop?
I don't know, but it shit smelled really good.
Like ice cream? Chocolate ice cream?
So, yeah, you have a problem. You have somebody watching us. That's no good. You have to be able to discuss everything as though nobody were watching, or else you don't understand it.
Well, the trouble is, you know, when you observe things, they change properties. Like it's the state isn't defined until someone observes it. So.
No, I mean, you and I can look at this. You and I can test.
Right.
Also, Wolfram.
So I'm totally distracted with this stupid. Oh my goodness, this guy is really infuriating me.
Well, it's the social justice thing, right?
It's totally funny. It's totally funny how the two of us, we disagree so much in the physics, then when it comes to the politics, we're like that.
Yeah, well, you have some sort of ulterior motive in physics, and you understand that politics is reality. So.
Yeah. Oh,
yeah.
I mean, not in the. I'm referring to your politics. I'm referring to your politics, not the physics.
He said
physics comes out directly. I actually did not derive those on purpose. Okay, like it came. I saw it. I'm like, this just fits together, and I'm like, I can cause some destruction with this now that I see it. Like, but it was not designed that way. It wasn't created for the purposes of doing that. It was. I ran into it. I'm like, oh, and this can be used for this additional thing. So.
Well, now, what was your line on string theory? I forget what you...
I said that I think it's partially wrong, but I think that there are portions of it that can be salvaged and, dismantle the theory, but then don't throw it out entirely, but take pieces out of it that you can then fit into another theory down the line.
You of course, don't take exception to it being called a theory simply because it can't be tested.
Right. Well, can't test it at the moment, which is a problem. And so the idea is you don't just if you can't test it at the moment, it doesn't mean you throw it out because, you know, you just treat it as what it is, as a theory that you can't really test. And so you say, we're not going to, you know, we're going to hold it with a grain of salt until we can test it, but let's keep it, you know, there and keep tinkering with the idea. And if it shows promise, it may produce fruit down in the future. So.
All right, you are king of America. How many university professors do you want employed on studying string?
Oh, I don't know. I mean, that's the whole question, isn't it? That's actually a question in physics. Lee Smolin, who's in loop quantum gravity, said they thought they were focusing too much on string theory. I'm not focused enough in the field of string theory to really say, have a proper opinion on that. But
let's look at a parallel situation, a situation that can't be tested, but it's a hypothesis or what we could call a theory. There has been a theory proposed that there are gremlins living on the far side of the moon that wear chainmail socks and manufacture buses and drink Pepsi. They hide every time we look for them.
Well, the theory with string theory is that they're not always hidden. You can in theory find, you know, clues as to.
No, if these gremlins are there, in theory, we can figure out some radar they're not aware of. So, how many university professors do we put on an
that's the question. That's the question.
Untestable, arbitrary, out of their fucking ass hypothesis?
Well, that's the question, right? Is how arbitrary is string theory? And I honestly don't have an. I think there is too much focus on it, to be honest with you. I think there is, like, they focus too much on it, and too much of it is theory. But at the same time, I also think that there is a kernel of truth in aspects of it, and I don't know. I honestly don't have enough information on it to really say, should we have more or less? I'd probably say a little bit less, but I don't know how much less.
How about we just say it's arbitrary until it's testable? Until and unless. That would be, why would that be inconvenient? Let me guess, you would find that inconvenient.
Well, no, the problem is that we have good reasons to believe that aspects of it are, like really strong reasons to believe aspects of it are true.
Of string theory?
Yeah, aspects, not the theory outright, but aspects of it.
The testable ones, the testable aspects.
Yeah, I think one of the testable aspects is Kaluza-Klein theory. I'm not quite certain how we go about testing it, but it has a. You know what Kaluza-Klein theory is? I'll explain what Kaluza-Klein theory is, and you might see why I think it has potential promise in the future.
Okay.
All right, so Kaluza-Klein theory is a precursor to string theory, one of the precursors, and it was kind of built after string theory came along. They said, well, if we add Kaluza-Klein theory to this, we can make string theory better, and it can explain more, and so on. So Einstein came along with general relativity in 1915, which, you know, he describes gravity as bent spacetime, and then they confirmed that with those parallax experiments a couple years, you know, several years later.
Yeah.
And since then, it's versioned and they can use it to like study astronomy, and it has numerous predictions that are all coming back positive. And actually now it's come.
You see how a theory works, then. That's how a theory works.
Right. And so now they actually got to a point now where they can. One of the last prediction that it made, that was like the one remaining prediction that was still, you know, out there that hadn't been confirmed with general relativity yet, was gravitational waves, which we've now observed those as well. And the cool application with that is once they refine the level of sensitivity of the instruments down a couple more degrees, which they're very close to that right now. And actually they're just on like the cusp of like doing like some short experiments with that already. They can actually use that to study the universe in a whole new way. Let's see, beforehand, you know, we usually just look at the universe and we say there's, you know, electromagnetic radiation, and we're limited to the electromagnetic band.
I have to put a sour note. I think that there's a lot of government boondoggle in these big science statements. Well,
I do know that my former alma mater was part of the LEGO experiment, and they did have some. So we heard back from this every now and then. They had, like, one of the rooms was filled with supercomputers analyzing the LEGO data. But the thing is they discovered gravitational waves last year, and now they've discovered them again at a stronger level. They actually found a cool incident where two black holes collided, right? And the point is, for example, dark matter. Now, you have some theories on dark matter, right?
Yeah.
And you probably like to see those theories, you know, tested, right?
Yeah, yeah. They're
Well, as it turns out,
in principle are testable.
due to the what?
In principle, they are testable.
That's the cool thing, is now they're in principle testable, and the reason being is dark matter, one of the main features of it is that it does not give back electromagnetic radiation. Before we couldn't observe any, right? It was just like this ethereal stuff that we saw had some kind of gravitational influence, but we couldn't really tell what, because it wasn't really, it was so ephemeral that we couldn't really get a lock on it, right? We could see some very vague things, but not really. The most we could really do was map parts of it, right?
Yeah.
Well, now they're working on this approach where they can sense gravity waves, and they can see, and like basically, it'd almost like be like, going from visual to infrared vision. Like now we have infrared goggles, and we can look at the whole universe with infrared goggles as well as light. But instead of being infrared goggles, it's light is the equivalent of EM radiation, and the infrared goggles proverbially would be the equivalent of gravity waves.
Okay. Okay. Go ahead.
So now, Kaluza-Klein theory, on the other hand, is now hold on. It's kind of cool. It was discovered by accident by a mathematician named Theodore Kaluza, I think, like the 1930s or 1920s.
Now,
Anyway,
wait. Earlier you said the guy who started string theory.
that was in the 60s. I don't know who it was, but it was in the 60s.
Right. And you said,
Kaluza-Klein theory predates.
you said the salvageable bits of string theory are
One of the main ones would be Kaluza-Klein theory.
that he proposed, and it skipped by me if you ever answered the question on what
Right.
he proposed that was testable that you say you would salvage from string theory.
I think Kaluza-Klein theory, but I'm not certain how quite yet. But I think that it seems to me that there should be a way to test it in a more robust way than some of the more, airy ideas in string theory.
Okay, well, let's turn to a more real subject. What about the CERN super collider?
Well, we did. That was useful for testing the Higgs boson, which was the last piece of the the grand model.
Well, that's focusing on a really neat tree that they found. Let's step back and look at the forest.
Okay.
They spent how many billions of dollars
Trying to find
putting whatever they've done.
Right.
What if it's a government boondoggle in the following way? What if we are like the ancient Babylonians who were just writing down the astronomical records of where the sun and moon set on which degree of the horizon each night, and had no idea why and thought it was messages from their gods? Turns out they weren't. What if we are like the astronomers of the Middle Ages that wrote down things? What if we're like the alchemists who were looking for gold and ended up creating chemistry, the nature of the science?
Well, that's the thing, right? So right now we don't know what we're going to find.
Okay, if CERN is useful, what if it turns out to not be useful for what we think it's useful for?
Well, that's the thing, right? It's kind of a question as to why, like we don't know until we find, but it may come back that it will be massively useful. We don't know what we're going to find down there, right? Here's an example, okay? Kaluza-Klein theory extends gravity to, basically said, Einstein's relativity was in 4 dimensions, 3-dimensional space plus 1-dimensional time. It's 4-dimensional space-time. Kaluza extended that to say, let's just play with the math and say, what if we had 5-dimensional space-time? What would that look like? That's in 5-dimensional space-time, right?
Well, let me interrupt.
No, hold on. I want to finish my
I just want to do a commercial. It's just a commercial. Ladies and gentlemen, go on Facebook and you can join this conversation by looking at my face on Facebook. Okay, if you had with 5 dimensions, what would that look like?
Well, it turned out that when he did the math, he found that it actually does fit something we know of directly, namely Maxwell's equations for electromagnetism. So from that, the Kaluza-Klein theory believes that, according to Kaluza-Klein theory, in the same way that gravity is 4-dimensional space-time, electromagnetism is bent 5-dimensional space-time.
Well, what do we mean by a dimension? Is we mean 5 nodes of interaction.
Yeah. So, well, they think that this particular dimension is
we're
curled
saying-
up real tiny, so we don't.
All we're saying is there are five nodes of interaction on each thing.
Yeah, but now the thing about this is if this is true, then you could, in theory, unify a gravitational explanation of gravity with an explanation of electromagnetism.
I think it's much more likely that there are more than 5 nodes.
Yes, but insofar that's why they go to 10 nodes for string theory, kind of explain the weak force and the strong force as well.
Pull the number out of their ass, but there could be nodes that we can't ever investigate. But Super Fin Guy, welcome to the late night. You're in Boston. You're as laid off as I am. Johan's out in luxurious California. He's 3 hours at our favor. But welcome to the shindig.
Yeah, hi. I'm glad to be here and glad that you made another hangout this weekend. And you have rats, right?
It appears that way, but I'm not sure. It may be a figment of a digital reality.
Yeah, it could be like a simulation, like a human simulation. So, but yeah. Usually Saturdays I go to bed late, so yeah.
This will be a regular night then. Good stuff.
Yeah.
Listen, have you listened to what Mr. Ratz has been saying? Do you want to chime in on anything, or do we just carry on from his 5th dimension or whatever he was doing?
Yeah. I say yeah. Let him finish.
All right.
Hey, Ratz.
All right. So what I was going to say is, if we can unify gravity with electromagnetism, and we have control of electromagnetism, electromagnets, superconductors, electric lights, etc. You could, in theory, extend that to, maybe, I don't know if it's necessarily the case, but what if you could, in theory, find that when you have this, this model developed, you could have something like electric control of gravity.
Oh, yeah, well, okay.
That would be useful, wouldn't it?
Electricity and control of gravity, so that's the electro universe.
Yeah.
So I'm saying, what if you could use that in a day-to-day basis?
Yeah.
That would be a cool thing if that was possible, right? That would be like.
That would be.
The sun would shine, right? Super Fin Guy. That's what's responsible for the sun shining so bright, where nuclear fission can't do that.
Yeah, exactly. It's more like an electrical phenomenon, an electrical arc, right? That because the light coming from the sun is because the sun has overall lightning, so it's like lightning 24 hours a day, all over the planets. And we have similar things going on in Jupiter and Saturn.
And Rats, you know that vacuum space has electrical charge or has a magnetic field?
Well, there are magnetic fields around planets, and I think the sun too. No, some planets don't have like Mars.
Vacuum space.
Some like Mars, for example, it doesn't have like a uniform magnetic field. It has lots of pockets, so to speak, of magnetic fields. So it's not it doesn't have like a nucleus similar to that one that we have on Earth. It has lots of lumps, I would say, of whatever makes the magnetic fields on most of the planets.
Well, it has a weaker fragmented magnetic field, but I'm talking about the work that's been done showing that an evacuated space with no particles in it has a magnetic field or a magnetic charge, wherein particles pop into and out of distance in negative and positive pairs and never violate the laws of second law of thermodynamics because they don't interact with other particles, and that is what causes talking radiation.
I'm not sure about that.
Well, it's the one particle goes in and the other particle bounces out and carries away energy.
Yeah, Yeah, I've heard of the virtual photons pop in and out of existence. I've heard
Well,
of,
I thought that was done in vacuum space.
yeah, they find energy in empty space.
Yes.
But
Well,
but
I
but
looked at
but
it, I
then
said
then
magnetic
energy could be
field
due
or
to.
charge.
Say again, please.
I said that the empty space has a magnetic field or a charge.
Yeah, it has a magnetic field.
You say
Uh,
energy.
yeah, you could say that, especially if that magnetic field is changing, it's oscillating.
So
Usually the magnetic field, I would say, is due to Birkeland currents and the electric currents coming from deep space. So, according to the electric universe, there's no such thing as an empty space. There are always, magnetic fields and electric currents going on.
that's the ether. Then we have the ether.
Yeah, we have the ether because the
Got it.
ether. Yeah, well, I would say that the ether is what causes the electromagnetic phenomena, like
So a
the
bit like
electromagnetic.
a 0 point field. It's often called a 0 point field today.
Exactly. That's what it's called. But yeah, back in the day, Maxwell explained the electric phenomenon based on the ether. The theory of relativity was based on the ether. Einstein stripped it of the ether, but so doing so, he left out a lot of things to explain because
It's
he.
actually interesting because my own personal approach to quantum gravity would actually bring back in something of a kind of ether.
Yeah,
Not
like
not in the conventional sense, but it would be something that would be a, instead of it just being empty space, it would be a kind of a substance to space. That is why it bends
yeah,
as it does. It gives
yeah,
it properties.
like the fabric of space.
It would sure help with dark matter, wouldn't it?
It
Hmm.
would.
If dark matter
But
got jumped up and twisted up around the edges of galaxies, that's the ether getting like the gravity well at the edge of a galaxy or something. Like the
yeah, it's
ether would explain redshift in a static universe.
like like I think the ether is nothing out of this world. It's like because if you look at it, the universe cannot have places where there's no matter because that would cause everything to rush into
Well,
you know
well, they
to
found
fill
it
the.
necessary for a long time until what? Until relativity.
Yeah, and until in the early 20th century,
Yeah.
they did Michelson-Morley experiments. They did that, and they didn't find the ether, so they assumed that there was no ether. But Einstein is very famous to say that a space-time without the ether is inconceivable. There has to be a substrate to all the matter that we observe in the universe, to all the phenomena that we see. You know.
Yeah.
But and also you guys were talking about gravity. Gravity could be, for example, it could be sort of like just like static energy. It could be, for example, a potential between mass and free ether that we find in space. It could be like a difference of potential that causes that attraction to the Earth. Actually, there are experiments that show that, for example, if you take any object made of any substance and you energize it, you will see that it will attract neighboring objects just like gravity does. It doesn't discriminate on substance. It just attracts everything. If you take, for example, a straw and energize it, and then you put that straw on top of a bottle, you'll see that it's attracted to anything,
Now
to a
that's
substance.
kind of brilliant because then you don't really need gravity to get the universe started, do you?
Exactly. It's all electric. The universe is an
But just
electric
try that
universe.
again. I do think there is I think there is more to the forces than how the universe works than gravity. But I think that
Well,
I tend to think of gravity as the fundamental force in some ways.
if the sun is 10 to the 24 tons of iron spinning.
Right, that's going to have a...
Oh.
Does it have iron? If it has iron, then it should have an electric. It should have a huge electric effect to it.
And then let's make a silly assumption, a very ridiculous assumption, that dark matter around the edges of the galaxy, whatever it is like a set of magnets around the edge of a spinning electromagnetic motor, and the stars are the glowing thing.
The problem with that is that dark matter, it should give off some kind of electromagnetic radiation to the interactions, right?
No, it's the nature of it to cause electromagnetic radiation. Now, I'm not a fan of dark matter, so don't find me... Yeah, I think electricity does it, and I think the outer edges of the galaxy are where they're focusing because they don't understand the fact that they need to focus on the phenomenon, not on where the phenomenon stops, because they're idiots. So I'm not a fan of dark matter, but if we have to be married to it, maybe it can be a mechanism of electricity instead of a cause through gravity of what's happening.
Maybe.
Carry on. My beer's empty. I got to get another beer. One of you say something about gravity or something.
Okay. Well, Rox, you were saying that like with things like, for example, the Higgs boson, we could, for example, engineer gravity. We could make anti-gravity a reality. Could
Well,
you
maybe
expand on that?
Higgs per se, but perhaps some kind of unification of electromagnetism with gravity via the Kaluza-Klein theory.
Oh, okay.
Which would be kind of interesting because it would open the door to if there was some kind of, it would be a way to study the electric universe too, because you'd have, you already model the universe pretty well with gravity, and if there's an electromagnetic component and we can unify electromagnetism with gravity, we could find some way to study that as well.
The Kaluza-Klein theory, what's it about? I kind of forgot. I watched a video about it a long time ago, so I need to.
It extends Einstein's general relativity to 5 dimensions, like a 4th spatial dimension. And then when it does that, it's able to describe electromagnetism as bent 5-dimensional spacetime, much as gravity is described as bent 4-dimensional spacetime.
So it added 5th dimension. And that dimension, for example, normal relativity, we have 4 dimensions.
Right.
Right. We have the 3 dimensions of space, and we have the 4 dimension of time. Right. So that 5th dimension would be what?
It would be some kind of thing that would be curled up. Like it would be. There's a couple of possibilities with it. First one. This is where the Klein part comes in. There's another physicist named Klein who suggested that the reason we don't see this additional dimension is that it's, compared to the other 3 dimensions, which you can see going on for, vast distances, this one is curled up such that it's like one Planck length across, something like that.
Yeah,
The other possibility is that we have like a 3-dimensional or 4-dimensional space-time, and that can actually, it's embedded in a higher dimensional hyperspace. And then as you, bend that 4-dimensional space-time within that higher, multi-dimensional hyperspace, that it creates, electromagnetic effects and so on.
Yeah, but that seems interesting. But this is all conjecture, right? Because
at the moment, yeah.
Uh-huh.
Very interesting conjecture because the math all matches up coincidentally, like exactly spot on, and they don't know why. But
well, the math could work, but you have to have a phenomenon in nature to
right. I know.
the math with. Yeah.
Hey, Wolfram does have a phenomenon that points to a situation kind of like this, where he says that the universe could be made of causal nodes or interactive nodes, items that are able to interact, and they could be tied together in ways that they're able to interact, and that's sort of how we would view it cognitively. And because of his simulations, he deduces this, and you can take it home if you like, but he deduces that there could be internodal connections of n, fill in the number, and that we are right now affected by 3 or 4, and that there could be n number, and some of them we're not affected by, but these n number of connections could be the nature of entanglement and so on, and some of the stuff that's being brought about. So
you said nodes. What are those nodes?
Yeah, Wolfram, a node is a central connection, as a center of connections that are connected to every node is connected to every other node, and all of them by the same number of connections by definition.
Okay.
I think that's what it is.
Yeah, sort of like a net, right? You have the points and you have all the lines interconnecting.
Yeah, exactly. So if what we call reality is whatever the fine grainness of the ether is connected by a certain number of nodes, the 3 or 4 nodes we take notice of, we take notice of 3 nodes in a given instance and 4 nodes over time, are just the nodes that are available to us or interact with us or have a causal relationship with. Anyways, I thought it was a fascinating idea, and if it's true, then there could be other things like, the fact that we can sort of mess with space, and we can mess with distance, and we can mess with but we can also mess with time. What? Well, that's because it's a node of existence, and so maybe there are more, and his mathematical description, Wolfram's, was fascinating to me, and take it home with you if you want, but
that idea kind of reminds me of the nature of the theory of relativity, where because everything has sort of like an angle of interaction. If you were to change that angle, you could access different parts of reality, like other dimensions. For example, when you accelerate at a certain velocity to near the speed of light, that angle changes. Like if you picture, for example, a circle, and you move, for example, a point on the x-axis, and from that x-axis go up. There's a line intersecting that point that goes up and intersects that circle. You can see that there's a change in the angle.
All right, can I draw a crude analogy? That if you're walking across the desert, you see individual rocks, but if you're flying in a jumbo jet, you see only mountain ranges?
Well, I would say it's kind of like that. It's the number of things that you interact with.
Right, so if you were flying really close to the speed of light through the universe, there are things that you wouldn't even notice.
Exactly, but
other phenomenon would become very, very prevalent.
Exactly, it would leave behind the things that we currently see, and we would start seeing something else. For example, like the phenomenon with relativity of time dilation, it's very simple to explain if you consider space as a sea of particles, because as you accelerate, the interaction with the ether becomes stronger, and that slows down the particles that make up matter. It slows down the electrons at the atomic level. Everything gets slower. The particles have a harder time to move around. So
you see, in Wolfram's view, that's just the number of nodes you're updating as you move, and the faster you move, the more nodes you're updating, and you have to go.
It's
a real effect. Yeah, that's a real effect, is to update nodes.
Yeah, it's sort of like that. Maybe the way that he's represented it is a bit abstracted. It's a more abstract idea, but the considering the ether as a sea of particles is a more of a like particular literal idea. So yeah, as you go faster, you interact with more particles. that would be the nodes, you know.
Yeah.
And yeah.
Well, and also not only the nodes of the particles you're bumping into, but also the light waves around you and stuff. And
Yeah, because if you take, for example, the ether as a normal medium, say like water, for example, the water has a certain velocity that waves can travel on. Every medium has a certain velocity, and the ether, it has a velocity for waves that is c, right?
and if you
Waves
that,
cannot go faster.
you
Say
break
again?
if you pass that crucial speed, you're like a breaking wave or something.
Yeah, exactly. You're acting just like that. You're disturbing the system, you know. Yeah, and for example, and if you take, for example, the resonant frequencies of the ether, you'll get to the different wavelengths of light. For example, it comes from X-rays to longer wavelengths. But if you break it down, you'll get to the resonant frequencies of light. You just have to know the speed of the medium. You know, they make it sound like it's very complicated, but it's something that we can see on the microscopic world, where, for example, the normal modes. I don't know, Rats. Are you aware of normal modes of a wave? For example, like a photon or phonon, like the normal modes.
Like, describe what you mean.
Like the resonant frequencies of a medium. For example,
Oh yeah, I know that they have resonant frequencies. Like
yeah, exactly. And the photon, it's nothing special. It's just the normal mode of a wave. It's and today they call it a particle, but it doesn't have to be a particle.
Now, what do you what do you mean by resonant frequencies? Can I go as far as music to understand it?
Yeah, it's sort of like say you have a string, right? And you vibrate that string, and the resonant frequency is that resonant where the string moves the with more energy, moves it stretches the string in a harder way. It's sort of like it's that frequency where the waves coincide. For example, the returning wave coincides with the incoming wave, so it turns the string into a standing wave, you know. So the vibration gets stronger, you know. So
Okay.
that's basically the resonant frequency of a medium, of a string, you know.
Okay.
Yeah. And the math for example, for a photon is the same. For example, like if you want to know the energy of a photon, you have to know, for example, the frequency of the light wave, and the constant, and what's the guy's name? I kind of forgot the guy's name. The I kind of forgot what constant. Huh?
Heisenberg?
Not Eisenberg. The other guy, Planck's constant. Yeah.
Hmm.
Yeah. You just have to have the Planck's constant times the frequency of the wave, and you have the energy of each photon. You know, and that is the same math, for example, that you use for figuring out the resonant frequency of a string, for example. It's kind of the same. You could substitute the Planck's constant with the energy, with the amplitude of the wave.
Yeah.
You
No.
know?
We have the energy of what? An ongoing event in space-time. Because it's not a particle.
Yeah, it's just a wave. It's just the energy of that wave.
Well, a wave of what?
Yeah, that's the question. I would say that it's a wave of the
So
ether.
according to Stephen Wolfram, we don't have to do either. We don't have to call it a particle or a wave. We can call it a causal event in space-time or something like that. A ripple in the nodes of the ether or something like that.
Yeah, but if you see like space-time are just sort of like relationship of something, you know. For example, you have, for example, in space-time, you have, for example, the density. You could look at space as the density of something, and you can, and according to that density, you have how slow or how fast something moves in it. You
Yeah,
know?
Johann Rotz loves that because he can use that for information processing as the basis of the universe, because information processors slow down when they have to process more information, which is near gravity wells where time slows down. So, but yeah,
Kind of a cool correspondence, actually.
yeah, no, we went over that pretty strongly the other night. Sorry to jump in there. I just wanted to point out that
They actually proved a form of that with Ted Jacobson's theorem in, I think it was 95. I think it was 95, but I'm not certain.
they mentally masturbated. But continue, Superfin guy. What were you saying? If I interrupted, I just wanted to point that out.
Well, you know, so that's how I kind of lost my train of thought there. All right.
All right. Well, no problem. I don't know what we were off onto, but no.
Well, we were talking about space-time, right?
Yeah.
Space-time and how Wolfram regards space-time.
Yeah, just that he allows it to be updating nodes, and that we don't even need objects. All we need is nature of whatever it was that started out before whatever we call the Big Bang. Were just interactions between things which changed over time and turned into the things we have now. And we can't necessarily take the things we have now and blow them apart and learn about where we came from. So
Yeah, I would say that we can only know the process that make them become what they are.
and we can know certain bits and back to a certain way. I think that what CERN is doing is they're uncovering fossils of some kind. And fossils of some kind.
Oh, okay.
CERN is like, it's like going back and discovering the missing bits and pieces of what assembled us. It doesn't really tell the whole story. There are probably bits and pieces missing that we can find later or something. And there are probably whole sections of the universe that are missing, like there are whole species that are missing from the fossil record. So I think CERN is finding fossils in a sort of a spotted way. They're learning about little bits and pieces about the nature of what reality is made of, but the universe isn't necessarily all going to be contained in a fossil record like evolution's history isn't.
Oh yeah, like with the CERN project, they're trying to find the so-called God particle that's supposed to be a very old particle, right?
Yeah. Get up for a moment, okay? Be right back.
All right. Yeah, and I don't know if you were on earlier before, but what I had been saying about that is that they're taking apart a highly evolved thing with a shotgun and, you know, trying to decide where that highly evolved thing came from. And that's not necessarily the way to go about it, and may not be much.
Me too. I don't think that's that's a very productive way, because all they're doing is like smashing particles together. They're like smashing protons and stuff together, and then when they get like a pattern of some kind, they say it's a particle. Like for example, with the God particle, um, what they found was something different from what they predicted. You know, so they don't know what they're seeing. You know,
Yeah.
and they always think of everything as you know. I agree that everything is composed of particles, but the thing is that just like in water, there are, you know, a substrate, like the particles that are smaller. You can't necessarily find them by colliding the bigger particles that are in water, right?
And who knows what we're going to learn from whatever comes out of it, whatever they learn about these particles. What if it's sort of like chemistry was for, the chemistry came out of alchemy, right? They
Yes.
They didn't know they were producing a science of chemistry. They thought they were going to make gold. Right?
Yeah, exactly.
And
Like,
what if today we are trying to find the nature of the universe, the origin of the universe, the origin of the Big Bang, and yet what we're doing is we're learning about subatomic particles and high energy particles.
yeah, and a lot of the particles they are claiming to find, for example, like the other particles that they found, for example, in the center of atoms, in the nucleus of atoms, are just patterns. They don't even know if they are particles. You know, so personally, I think that matter is made out of two particles. You know, electrons and protons. The other particles that they say exist, they don't really have evidence for them.
Really, that's quite interesting. I've never heard such an idea.
Yeah, and I think a better way to try to find out the nature of the universe is just like Huygens did. He used logic to deduce, you know, the process of the universe. For example, you can make an experiment. For example, you say that a certain phenomena is composed of two waves, for example, and then you make a hypothesis that if you combine that wave a certain way, you'll give, you know, a certain result. You know, so if that result is true, if it's in fact what happens, then you can deduce that a certain part of nature is made that way. You know.
I think that's backwards. You start with observation and then you go from there. So what?
Well, yeah. You observe certain things and
What
then.
did he observe?
Huh?
What did he observe? Why do you? No, what you did was you made a little thing and said, if I find this conclusion, then blah blah blah. But the little thing you made is the most important bit. You can't just say, if I find this conclusion, because it's what you made the thing out of. It's what you now.
Well, for example, with light, we observe that light passes through two beams of light pass through each other, right? And because they do that, light cannot be particles flying. It cannot be the actual particles moving from point B to point A.
Now you're saying perpendicular light.
No, not perpendicular, like facing beams facing each other. Like if you take, for example, two beams of light and you shine their light on each other, the light from one beam and will be unaffected by the other one. You know what I'm saying?
Yeah,
Like,
is that true? That's quite fascinating.
It is true. It is true. Like if you have two sources of light, they will not interfere with each other. You know, so that led, for example, Huygens to deduce that light is a wave. It's just like a movement that is transmitted. It's not a particle that is transmitted.
Well, can they interfere with each other if their resonances resonate or whatever?
If they resonate, they can make a standing wave. But the energy. Say again, please.
The room would be totally dark.
Oh, well, if you have a destructive interference, the waves will cancel each other out. But the thing that a real lamp or beam of light has lots of frequencies. It doesn't have just one frequency, right? So some frequency will destructively interfere. Some will constructively interfere, but the light will pass, right? But if you have two beams of light with exactly the same frequency,
laser,
and a laser, for example, and they destructively interfere, you will have like a dark spot there, you know.
That would be fascinating, a dark spot of energy.
But that can be seen, for example, in the double slit experiments. Like, for example, in the double slit, you have two beams of light. They pass through two slits, and on the wall, on the next wall, you see just just strips of light.
Yeah, it's just
In the
dark.
middle, exactly, because on those parts the light destructively interferes. So it is observed.
Yeah, so that's how fascinating it would be to look at two lasers who were pointing at each other and synchronized.
Synchronized with the same frequency, they will cancel each other out.
That's how fascinating it would be to look at them here. But what if they were synchronized, and if you interrupted them, then they would both, and so it would zap from both sides whatever interrupted them.
Like, for example, if they were perpendicular, or
Yeah, facing each other
uh-huh.
and synchronized, so that they didn't do anything. So they were dark, whatever that means.
Well, if they are synchronized, they will constructively interfere. They would become stronger, right?
Stronger, and then so what if somebody stepped in between and interrupted that, or they blow each other up? They'd resonate till it blew each other up.
If you put, for example, something between them, it would just block the laser. It wouldn't do anything, you know.
Oh, come on! I'm trying to come up with something to blow somebody up with. Come on.
Well,
I failed, huh?
well, I didn't really kind of get your point, but
They have lasers that are strong enough to cut your flesh and do things.
yeah, they do. Like, so that proves, for example, that light has real energy, you know.
Well, like we were talking about the other night, I said that Earth gains either 4 or 8 pounds a day of light.
Yeah, exactly. Like if you concentrate light enough, it will act just like a particle. And Einstein actually said that matter is a concentrated form of light, right? Matter can be seen as a how can I say this? Like a construct of light. It's just light in a certain pattern.
Why do you say light? I understood it to be energy, but I guess light and energy are equivalent, though.
Yeah, I mean light, transports energy. Just like rock is energy, right? If you throw it, it's energy.
So mass is cold energy.
Yeah, well, or structured energy, right?
Well, energy that slowed down.
Well, it's not exactly slowed down, but I would say trapped, just like a standing wave, you know.
Well, what do you mean? So I say a criminal's been slowed down. You say he's just in a jail cell.
Well, oh yeah, okay, but he's in a jail cell moving around in a circle, right?
Yeah, so he can no longer go 60 miles an hour, ever.
He will go 60 miles an hour, but in a circle in the cell, right?
No, he'll only go 5 miles an hour to circle in the cell. So I win. If you put him in a cell, he slowed down. So the nature of locking up energy is to slow it down. So matter is cold energy.
Well, I wouldn't say it is cold. I would say that you slowed
I just did. I would say that.
Well, I'll say that you sort of like stop the guy from going anywhere. You just have him walking in circles.
Yeah, it's cold.
Well, yeah, I guess in a certain way.
And admitted it's a brilliant analogy.
Who admitted it?
You have to admit that Einstein came up with a brilliant analogy when he said that matter is cold energy that's slowed down.
Well, I guess, yeah, because it's not moving. Because, for example, like with heat, heat is just the particles in motion, right?
Yeah.
So if you have them not go anywhere, you could say that there are like colder.
Yeah, isn't the heat death of the universe depressing? Do you get depressed by that?
Well, I don't think that the universe will ever get inert or will ever reach equilibrium, because I think the universe is not a closed system. I think it's an open system. I think we'll always have a continuum.
Yeah, I agree with you on a certain level. Even assuming the Big Bang isn't true and that it's a static universe of some kind, I think it's an evolving universe, And
It is, yeah.
I think that the heat death may be true, even even though the Big Bang is not true. And I think that the heat death may be in the far future in our evolving universe, with disregard for the heat.
I said awesome.
Big bang.
I saw a new movie today. It's the second Independence Day movie.
Say again, I didn't get that
Independence
last
Day,
part.
Waiting for Rats to get done with this.
Yeah, the other one down in
What's the name?
Independence Day Resurgence.
On national TV.
On the alien invasion. Yeah. Yep.
$3?
Well, when it comes around, it just opened recently, so it'll probably be fine.
Super thin guy came to Boston once.
Okay.
Exactly, it was $12.
Parks down.
Like recently or
Well, it was
some time
in
ago?
Norwalk.
Okay.
Yep.
So it's not.
And I parked downtown somewhere
Yeah,
Okay.
not yet.
and walked
It's gonna
around,
always be the old
had
one.
dinner.
What street was it? Do you remember?
What was it? What?
What street?
No, I have no idea. It's they were in the middle of the big dig. It was all going on.
Okay.
And so we got back to the car, and I was expecting some sort. I didn't know what I expected. I expected to pay for nose for parking, right?
Yeah, usually downtown you have to pay for parking. Yeah.
Yeah, I thought 28 or something, 40 maybe. It's $130.
Wow.
Are you kidding me? That's insane.
Yeah, that's why when I go downtown I never park. I just take the subway. You know. Boston, downtown Boston can be very expensive, almost as expensive as New York, as Manhattan.
I don't know if I've paid that much for parking in Manhattan. I might have
Really? Yeah.
been a Jewish parking garage or something. Rats, I don't know what you're doing. You're killing us. What's happening over there?
Yeah.
Rats,
Rats.
get your mic.
Hi.
Kill me. Got
What?
it? Control here? We're here. All we can hear is the sheep running past your microphone.
Oh, that's weird. I don't know. I'm hearing someone else, like, clicking or something.
Oh, that's Super Fin guy waiting for your sheep to quit running past your microphone.
Yeah.
I don't know. I'll just, mute for now.
Yeah.
And that sheep out in the yard. All right. I don't know how much more we can cover about protons and neutrons. What about more real stuff? Did you guys hear about the slip-up Elon Musk's SpaceX public representative slipped up in an interview and said something she shouldn't have? Did you hear about that?
No. What did the representative say?
Somebody asked her about the large rocket, what the large rockets were, what they were intended for or something, and she said, "Oh, you mean the Mars, or I mean the Red Dragon?" And
okay.
why did she slip up and say the Mars rocket?
Oh, the Mars rocket, because I also heard that that the main goal of the SpaceX was to go to Mars and terraform Mars.
Yeah, and so they haven't announced that. But what they've said is that this is big enough to take a capsule of some kind to the moon and lift things into low Earth orbit for the space station and stuff. And so that's the only evidence we have that they are actually, I mean, you know, we know Elon Musk. I guess we're not all in the dark, but that they're actually really so. Anyways, this booster that they have, a central booster can send a satellite up. You put two little, a central rocket can send a satellite up. You put two boosters, one on each side, and it can send up some really heavy thing for the space station. You put a third booster on it, it can send up extremely heavy things for the space station.
Oh, like it can take like a really heavy load.
Yeah, but it has space around the bottom for 9 boosters, or maybe it's 7. I can't remember.
Really? Like that's the SpaceX rocket?
Yeah, it can be configured that way. The SpaceX Dragon, Dragon, I think.
Red Dragon?
Red Dragon, Dragon Heavy, Red Dragon Heavy. I don't know what it. Yeah,
Mhm.
you know what I mean. But it can be
Uh,
configured with up to 7 or 9 boosters, and you know each booster that it adds on is much more efficient than
then just a few.
than the original, and then just a few. Yeah, it's sort of like resonance or something.
Hmm.
Yeah, it
But as they add the boosters, that would require a lot more fuel, right?
yes, the fuel's quite cheap. It's not
Mhm.
that bad.
Uh-huh.
Especially
I mean,
rockets are
I mean,
reusable.
they would have to make like a huge container for the fuel. Like the rocket would have to be longer or bulkier.
Well, it's even worse than you suspect because they're planning on doing one every 6 months.
Oh, really? Wow.
Uh,
Yeah.
and now, if that's true, they can send. And the thing is that I think with every launch of a 7 booster central rocket system, they can do a 99-man mission to Mars.
Really? Wow.
And if they do that every 6 months for 10 years, and
Mhm.
of course, you know, it's just like the Human Genome Project. It would ramp up over time.
Oh, like the rocket would get more efficient over time?
No, other companies would join.
Oh, okay, yeah, yeah,
They
something
would
like that.
open the second assembly line, a third assembly line. You know, China would
Yeah,
start sending people to the moon. China's
yeah,
always going to fail. China's destined to always fail.
yeah. Everything they have is copied stuff, you know. So I don't think they will innovate on that. They will wait for us to do something, and then will try to imitate.
Trying to
Right?
imitate. Do you
Yeah.
know about Russia when the Concorde was being developed? Russia tried to steal the plans for it. Do you know about the history of that?
Yeah, I think that they built sort of like a version of the Concorde,
Well,
and it crashed like several times, and they discontinued it
you know why? We
because yeah, go ahead.
we knew that it was being the system was the program was being infiltrated, and
Mhm.
the French put leaked false information to them, bad mathematics that they never
Oh, really? That's genius.
figure it
Okay.
out.
Yeah. So they knew that they had spies, right? Wow. Yeah.
Yeah, well, France was 30% Communist Party in their parliament at the time, so Italy was 42%, so it was a disaster. Mr.
Huh.
Ratz has gone completely out of the universe.
Yeah. He's muted.
Yeah, he can't hear
Oh,
us.
hi.
He can't. Oh, because then
Okay.
you couldn't. Then you're not. You have no effect on us. Therefore, you don't exist. So it was very strange for a moment.
Yeah. Yeah. Continue with the Elon Musk rockets with the SpaceX rockets.
No, that.
I'm a little bit.
Go ahead.
Yeah. Yeah. I'm a little bit skeptical about that because all I've seen is the rocket, take some load and take it to the space station, and also they tried the landing system. I think they succeeded once, but most of the landings are just failures.
Oh,
So
everything fails in life. Nothing comes to fruition. There is no God. The sky is empty.
yeah,
But
yeah, but
but
but yeah, yeah, but we can surpass those problems. Yeah, but I'm very suspicious of Elon Musk. I think the Tesla car was a nice project, but it was something that existed before. For example, the new transportation system that he's using between LA and San Francisco, that transportation system is nothing new. It's a maglev train with a few improvements, but it's a maglev train.
yeah,
Yeah, and also he came forward to say that artificial intelligence could be something very dangerous. You know.
No,
So
I believe that's basically true, and I think that it is right now. I mean,
why?
I don't think
Why
we should wait for his prediction to come true. I think it's here.
the artificial intelligence is dangerous nowadays?
Yeah, what is China doing when they steal our bank stuff?
Is China, hacking banks with the help of artificial intelligence?
Yes, of course.
Oh, really? I didn't know that.
How else would they hack it? Well, they just stole 7 million government employees' tax refunds.
Really? Wow.
I mean,
And they're
what kind of information is that contain? You know, everything about those government employees. So, how safe is, or I mean, when was the? I mean, when you heard about Target, right? Target being targeted by. That's funny. Target was targeted. Did you remember this?
But it was targeted by hackers, right?
Yeah.
But no,
What?
well, I guess if the hackers are using some sort
Pencil
of
and paper.
Say
They're
again?
using pencil and paper.
Well, they're using their computers, but they're using like tools, programs and stuff. But I wouldn't say that they're
That's
using.
that's the danger. Okay, we're going to face things that are smarter than human beings, that have no values, and are the total slaves of the inventor.
Yeah, you could say that. But I guess those machines, they will be only good at calculating. They wouldn't be good at, for example, at making concepts. And
That's what we have already, though.
we have computers that can make concepts.
So no, they are better at humans than at calculating.
Oh, okay, yeah.
They're
But
better at
humans.
humans than trying millions of things every second.
Oh, okay, yeah. But
So we've already got Elon Musk's worst nightmare. We're
well, no,
only looking at future iterations.
well, not really, because for example, there are encryption systems it would take like a huge number of tries for you for example to brute force a password. You know,
Right.
that would take like years. Maybe they have like farms of computers, maybe that could do that less time. But I wouldn't. Yeah, I guess that's dangerous. But for a thinking computer, that would be real AI. Like,
Why does it have to be thinking, though? Why can't it just be really, really brilliant and used by a bad person?
yeah, I guess that could happen. Yes. But we would have defense against it, because if someone can do it, if someone can do a really smart computer, you can make a real smart computer to counteract it. You know. So
Yeah.
for example, in banks, they have very good security systems, that could counteract the Chinese attacks. But I wasn't aware that Chinese hackers actually succeeded in hacking a bank. I wasn't aware of that. That used to happen, in the 90s when everything was new. But nowadays, that would be very dangerous indeed.
Well, when I say hacking a bank, I mean identity
It's
fraud.
not a surprise. I mean, they were hacking the Pentagon before, and that was actually amateurs.
Yeah,
hacking
amateurs.
there.
Yeah, exactly.
Now, that was
And
not even like their cyber security force, which I'm sure could do a lot worse. So they like doing that for some reason.
yeah, like there was a guy in UK that actually hacked some computers in the Pentagon, because the router that they were using had the default password. So it was easy for them to just get into the network.
Now people get hacked all the time, and their bank cards get stolen and stuff. And if that's not information, I mean, if that's not an example of the use of AI,
Intelligent. Yeah.
That's AI, right?
Yeah,
Now
but for example,
that's just AI that's really good at math. What happens
yeah,
when you have AI that's good at slightly more than math?
yeah, an AI that can actually, make concepts and do regular thinking.
What if it can't even make concepts? What if it just knows enough about billions of humans worth of hours and hours of information that it knows what you are going to do next much, much better than you do just by just the way we know quantum mechanics.
It'll be kind of like the computer on Eagle Eye. Remember that movie?
I've never seen it. I don't watch movies.
It's a good movie. There's Shia LaBeouf in it, and so.
Oh, okay.
Anyway, it's a Pentagon computer that security system that's artificially intelligent, and it decides that the president is a security threat to the country, and not just the president, but like a bunch of other people in the cabinet, and so it conspires to assassinate the president via a very clever system, and it has people in charge. It is actually manipulating people into doing actions by setting them up, like manipulating police databases and saying, the police are coming for you. You better do as I say, and then it's able to, direct traffic and direct lights and tell what's going to happen, and it's running people around and it's killing people. And like one time there was a guy that you had to get rid of, who was part of its plan, and then it sent a whole bunch of electrical charge down power lines, such that it shorted the power line, blew the power line out, and it power line landed the guy and like incinerated him.
Oh, okay.
And it was the computer was doing this by design, and it was getting scary because after a while then it took over remote drones and so on, and it's if you scale that concept up somewhat, give it nuclear command codes, so you got Skynet.
Yeah, but I think that a computer that can actually think such things, I think would act more carefully, and it would think about the bigger picture instead of.
Well, it depends what values it has, what goals it has for the bigger picture.
Yeah, but for it to continue doing its thing, for it to achieve its goal, for example, that is the national security, for example, it would realize that acting in such a way would endanger the country.
Well, you saw, for example, the movie I, Robot, where it was talking about that was a different one where the computer wanted to take over the world not because it wanted to kill humanity, but because it thought that humanity needs saving from itself, and so it therefore had to impose martial law with.
And the point that it wanted to kill the president is a very good point that I think that the elites or the people in the governments wouldn't want an AI, because an AI would cut up on their lies and irrationalities like instantly,
Yep.
So it would want to get rid of them. It would actually expose them.
No, they're the ones who pay for it, and they're the ones who have control of it by law.
Yeah, well, they would have control of it, but if the AI has some sort of autonomy, it could figure that out. Maybe to break free or how to stop them, something like that.
Yeah, but what if here's the more terrifying thing. What if it doesn't and can't? What if it just gets smarter and smarter and smarter and continues to be a slave of whoever controls it? That's what I'm really scared of. Not that it'll become intelligent and have concepts, but that it won't. I mean, that's what we're dealing with right now. We're dealing with an entity that can, when you put up a mathematical wall of 29 billion to the 19th calculations, it can break through that, or whatever.
Yeah, it could do that. But for example, there are systems that after a certain number of tries, the system shuts down. So then that could be avoided, for example. But a lot of the hacking.
That too.
Say again?
Well, it would find a way past that too. I mean,
it could, yeah.
But
for example, a lot of hackers, they find out about passwords with social engineering. They call the person, they try to manipulate the person and they make it that the person gives them a certain information that they need, you know. That is, for example, that's much easier than brute forcing a password. Or you can send phishing attacks where you send a person an email with representing, on a website, and then you ask that person to input their login, and that way you can steal their passwords. A lot of hacking is done that way when people gain access to databases, like for example the one that from the bank that the Chinese guys got a lot of information about the employees.
Hmm. Yeah. I mean, that's that's what we're up against. It isn't a smart computer; it's a dumb computer we're scared of.
Yeah, it's sort of dumb, because it just make the calculations. But yeah, I see your point. If someone can make a program that has it can make concepts, but you provide the program with a concept, with a certain programming where it can predict certain things, that could do a lot of things.
Yeah, you probably are aware of that experiment they did when they gave a computer the instruction to make a certain number of pixels motivate themselves by a certain small number of physics laws from one side of the screen to the other. And it invented various walking and worming and squiggly things and different things. And it invented some very weird things, like a V with a large thing in the middle that just sort of did this.
Oh, okay, to go from one point to another.
Yeah, and it evolved things which we didn't even, that don't exist. There isn't anything with 3 legs and 1 leg. And
That is pretty cool. I think that is analogous to natural evolution. You know, when
Yeah,
you have like a process of evolution, and it finds a way, for solving the problem that it encounters. Yeah.
that was on a Discover Channel series about evolution.
Oh, do you remember the name of the program? Because that's very interesting. How in the past I've been looking for programs like that. Then you can.
I purchased it back
Mhm.
in about 2002 or 3 or 4, so it's quite old.
Uh-huh.
And it was just Discover Channel, a very long series on evolution, and back then there weren't that
Uh-huh.
many. So if you
Oh, that's pretty cool. Yeah.
Amazon or stuff, it was absolutely brilliant. It was a huge, very long, very, very good thing on evolution.
Nice. If you want, you can later on. You can send me the name of the documentary of the series,
Yeah,
and then I'll look up the program you were talking about. As
yeah.
you said, if it's from 2002, maybe someone made a small program that does the same. You
Well,
know.
I know that parts of the whole thing are on YouTube, so I can
Uh-huh.
find some bits and send to you. But yeah, I thought that was absolutely fascinating that they could use.
Yeah.
They just take evolution and program it into the basis of what a computer does, and the computer
Yeah.
can evolve things, because how quick is a computer able to evolve things? It can do 1,000 different walking mechanisms, and only one of them makes it to the other side of the screen. So then it takes that and it makes 1,000 variants of that, and one of them makes it faster, and then you
It,
keep
it takes.
a million times, and pretty soon you have little worms and stuff.
Yeah, yeah, I can see that. Or the program calculated the best way for it to go across the screen.
Well,
Not necessarily a trial and error thing, but
that's the point, is that you can't do it better than a trial and error.
yeah, yeah, you
It
can, yeah.
it did calculate the best way, and
Oh,
then
great.
and then and then it took that, it calculated 1,000 best ways, the best way it could come up with 1,000 times, and
Yeah.
it tried every one of them, and it took the 100 best or whatever and made a variant of each of those. So yeah, I
Very
think
nice.
there's a big future in sort of evolving the sort of artificial intelligence using evolution to
program.
things in an abstract way that are then used in the real world.
Yeah. Like, for example, you could, for example, like in that case of that program, its only goal was to get across the screen. But what if you give it a more elaborate goal? You know, it could make you say you want, say for example, that you wanted to invent something to fly, for example, that it has to go up, right? And you give it certain laws of physics, and it will try the best way to do that. You know. So,
Yeah.
and the computer could, for example, invent anti-gravity, for example. You can give it the laws of physics. You say, don't use anything with air, right? Just like if you're in a vacuum and you want to go get from point A to point B, right? Maybe it'll come up with something. So that's very, very cool.
It's as a wild hypothetical, but yeah, taking a computer and letting it do millions of evolutions of an idea within minutes is potentially quite powerful.
Yeah, it is. It is.
Whatever it is you want it to do. Now,
Like,
just to change a little bit, do you know that the SpaceX engines that they are using are printed?
they are like sort of like 3D printed.
Yeah, they're printed on a 3D printer that prints like titanium and cobalt alloy and stuff.
Wow, nice. That's very cool. Yeah.
They're not cast, they're not machined, they don't have potential fracture points.
Mm. Yeah. Nowadays, a lot of companies they are not using molds and stuff. They just 3D print everything they need because now they have the technology.
I can see that being a huge future. And what if computers were given the power to make, and what if an AI were given a 3D printer?
Yeah, that would be something. Yeah. Well, like everything can be used for good or for bad. You know, I can take my car, I can, go on a ride on it, on a joyride, or I can use it as a lethal weapon, and
Well,
run over people. So
let's use that example. And what are the most magnificent cars in the world today, or let's say the most expensive?
I would say the McLaren, or
How much for a McLaren?
I think it's something like 300 or 200,000 dollars or something.
All right.
Oh,
Well,
there's the Bugatti that's like 1 million.
yeah, it's
But,
$1 million for a
$1 million.
Bugatti.
Yeah.
Well, now I'm talking about an internal combustion vehicle. You get in, one man can get in it and drive. What's the most expensive?
I think it's the Bugatti. I think it's the Bugatti.
No, sir. I'll bet it's the M1 Abram.
I'm not aware of that one.
$65 million tank? Or not? I'm sure it's not. It's 6.5 million. I'll bet.
For a car?
How much is the M1 Abram tank?
Oh, okay. It's a tank. It's a military tank. Yeah.
Well, what I'm saying then is that the most expensive and most elaborate versions of things won't be the consumer version.
Yeah, true, very true.
And that'll be true with AI. So what they're doing with AI is they're trying to figure out in what way Russia, in what way we could send our missiles so that Russia's missiles would do the minimum damage to us and ours would maximum damage to them. And they're spending millions of dollars on those calculations. Not only those, but other things. So, and bank problems and stuff. There's a war going on with banks no one will talk about, because what if they talked about it? You don't think that the millions and millions and millions of dollars of theft in this world at some point get pointed towards computer systems at banks?
I agree, yeah. So and that's why we need to get the bad people out of the government, or at least restrict the power of these governments and how much money they can control. You know.
That's all fine and dandy, but you know that if men were angels, we wouldn't need government, right?
Well, true.
So,
I think mankind it's benevolent.
so
Uh,
you say let's just get the bad men out of government, and I say not going to happen. My solution is
mm,
hope that you live in a good time. Try to live in a good time. Educate your kids. Talk to your neighbors. Do what you can, but have a gun and be responsible for yourself.
exactly. And that's one of the things that can stop, you know, the minority of bad people. It's guns. It's not gonna be arguments. It's gonna be guns.
Yeah.
You know, because those people, I think those people can, you know, stop, you know, destroying the whole world is by bloodshed, I think, because other way they will be not be, they won't go away. You know, I think they'll start to go away. People get better protection from them. You know, for example, in a time, say in the future, where someone could have the firepower of a of a jet fighter, for example, today, because weapons do evolve as well. For example, like 300 years ago, people just had muskets, and now people have automatic guns, even bazookas or flamethrowers, you know. So I think when we get to that part, I think things will start to equalize,
Well,
you know.
you know that violence has gone. You know Steven Pinker's work on this. That violence has gone down.
Yeah, I agree because more people have guns today,
Yeah.
right?
Probably because more people are armed. It's maybe why we've
Yeah.
got violence. More countries are armed, and it's not as easy to invade. You can't just go and take and invade a village or something now like you could.
Yeah, exactly. You can't go the Viking style anymore, you
Yeah,
know.
more
And
people are armed.
yeah, and you can even go Hitler style today, because that will be suicide.
Well,
You can't go on the blitzkrieg today.
what happens when a whole society systematically disarms?
Well, it's just the bad people will take over. You know?
That's what happened in the 30s, right after World War I. Everyone freaked out and disarmed because they never wanted war again.
Yeah, but they failed to realize that the ones who started the war weren't normal people. It was the rulers, you know. So yeah, they disarmed people and they got more power, and the governments and the rulers at that time, they realized that they could, you know, attack neighboring countries, and they did, you know.
So
And now,
what happened after the end of the Cold War? You say, and now?
well, after the Cold War, we're again in a Cold War, you know, because Putin, it's like doing sort of like in a Cold War with Europe, with the EU, you know.
Yeah, but it took. Notice the Cold War ended in 1990. Here we are, 20. That's 25 years it took for us to sort of. We had like this really peaceful honeymoon of some kind. I know September 11th, 2001, and
Yeah.
and so on. So Islam was a growing theme throughout this new Cold War that's now starting against Russia, or maybe Russia's going to be an ally against Islam. Russia was an ally against the fascists, so why not this time?
Well, I think now the fascists are the people from EU, you know. For example, like the Russian helped Syria, you know, fight against ISIS, you know, and now Syria is taking back their country back, you know. They are
Well,
taking their
no,
country
no,
back.
no, 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 no. Come on. I just have to say that Russia is only interested in Syria because it's their only warm water port.
Yeah, maybe, yeah, you could say that, yes. But they, at least they helped the Syrians. Maybe they have just that
They
interest,
don't
but
care about the Syrians. They only do it.
yeah, you could say that.
Their interest in Syria goes back to World War I. They were interested in Syria 100 years ago because they have the Black Sea, their warm water port in the Black Sea, which is garbage because it goes through the Dardanelles, which is controlled by Turkey, and then they have Syria. They have no warm water.
Yeah, exactly.
They have up in the Baltic, they have Belarus, which is just a puppet, and then they have Vladivostok over in the Pacific, which is useless. So they have no warm water port. They can't. Their navy has no useful warm water ports without Syria.
Yeah, very good points. Yeah. I think they're trying to protect their assets in that region. You know, they don't really care about morals or the Syrians. Yeah, I see your point.
You know what Putin? I don't know. I don't think it's true, but Putin said about playing chess with Obama. Did you hear that?
No. What's up with that?
He said playing chess with Obama is like playing chess with a pigeon. The pigeon knocks all the pieces over, shits on the board, and then struts around like he won.
Really? Oh my God. Yeah.
True, but
I would agree with that.
Yeah, he's been quoted as saying it. I don't know if it's true, but it's brilliant.
Well, geopolitically, Obama is kind of doing, that, I guess.
Yeah, is it true that the military generals of the United States have initiated hearings against, let's see, they've indicted CARE as a criminal organization, and they are investigating Obama as aiding and abetting the enemy or something like that. Have you heard this stuff?
No, I haven't heard of that. But I'm not surprised at all.
It's probably Alex Jones nonsense. I don't know, but the CARE thing I think is real. I think CARE is being investigated as abetting criminal organizations or something like that.
Wow. Yeah, because if you noticed, Obama is actually arming the rebels in Syria, for example. He's not protecting the West.
Yeah.
You know, the war that broke in Syria is his fault. He armed the rebels. You know, he tried to get rid of Assad. You know.
And you heard about Afghanistan? What's going on in Afghanistan? You tell me what you know.
Well, as far as I know, is that the war over there is kind of over, but the government there, they don't actually have control of the radicals over there. I think it's a mess right now, right?
What about the Taliban? You know about that?
Yeah, I think the Taliban are coming back.
Do you know that we're having talks with them?
Oh, really? Like the Obama people?
Yeah.
They're trying to negotiate with them.
Or negotiate with them as a political presence or something. As an Afghan political presence or something, whatever it is. Isn't that outrageous for us to talk to them?
Yeah, that's unbelievable. You could say that they lost the war, right? But Obama, I think Obama doesn't care, because Obama seems that he's on the side of the terrorists.
He's a Muslim. He's a fucking Muslim.
He's a Muslim. His name should have gotten him away, a long time ago. Osama bin Laden. It's like Obama. It's like just like other Muslim men.
There's so many evidences that like the State Department is now like under Obama is connected to ISIS. I mean, State Department or CIA. It's only under Obama. There was some evidence that like it was actually started as a CIA operation, and then
our director
supposedly started to help combat Assad, and then supposedly it went haywire, right? Which no one really believes that, because now they're funding like terror. They're actually funding like funneling weapons and so on to ISIS. It's ridiculous.
Yeah, it's ridiculous.
Go ahead.
Well, if you look, for example, the equipment that ISIS have is just American hardware. They have the tanks.
That's what I was going to say. You know that big abandonment of the troops had to leave like 2,000 Hummers and rocket missile things and ammunitions, and they abandoned it. They were running from ISIS.
Wow, unbelievable.
And 2,000 armored Hummers. Now what?
They got scared.
Well, I heard this in a Trump speech. He said we couldn't bomb the Hummers. We didn't have a cruise missile. We could just, we had to let them have those.
Yeah.
Really? We had to let them have them. We couldn't destroy them.
Probably they were ordered to step down.
Yes, of course they were by the traitor in chief.
Yeah, exactly, by the Muslim in chief. Just like in Benghazi, Hillary Clinton told the bodyguards, not to interfere with what happened at the embassy, So
Yeah.
so I really hope that Hillary doesn't win, because if she wins, it will be a problem. It will be Obama 2.0.
There'll be a civil war.
Yeah.
Now, you know what? I don't think it will come to civil war here, but it will in Europe. Europe's already there.
Yeah, it's pretty much there, and I'm really glad that United Kingdom left the European Union. So I think that's a step in the right direction, with the UK leaving.
Yeah, that's excellent. What I am afraid is going to happen is that they are going to use, that there's a 2-year exit clause.
2-year exit clause?
Yeah, so the European Union can initiate the 2-year negotiation period.
Oh, okay. So it's they'll try to negotiate UK back into the European Union.
Who knows?
Yeah.
It's
I think
it's to exit.
I think
it's in the treaty that to exit, there's a 2-year negotiation period. Now, during that 2 years, they might negotiate better terms for the UK or a special deal for the UK.
Yeah.
But Mr. Juncker, whoever the hell he is, the president of the EU, has said that he doesn't think that 2 years of negotiation is wise, and he wants to get them out as quick as possible. And I think that that's just political nonsense, and that he's going to absolutely strangle them for the next 2 years.
Yeah, exactly. Yeah, I think
and
so.
try to get them the most.
Just like the United States, the Feds did in the beginning of the United States, where they forced a lot of states to join in. So
I'll have to go over that a little more sharply. I don't recall.
I think it was Long Island was forced to join the union. Because I don't remember the specific details, but I think it was a tax thing or something like that. But they were forced, they were pressured to join the union.
I don't feel very sorry for them. You were taken over by the greatest country in the world.
Well, yeah, exactly. But it's kind of they were forced, and not even just Long Island. I think there were other states that were forced to join.
Well, is this a parallel to the EU, or is the
Yeah, exactly.
more of a parallel?
It's a parallel to the EU. So because they might force other countries to join them, so they can come up with a super state, with the United States of Europe.
Okay, so let's imagine that Britain. Let's imagine Brexit fails, and 2 years from now, Britain is basically back in, and maybe they've even accepted the euro. That would be hilarious.
Yeah, then that would be really bad if they accepted the euro. I think the UK may be the last hope.
Let's hope that they do well. If they do well, it'll follow dominoes in the other direction.
How many people in Britain think that this is a replay of World War II, where they are the last hope of tyranny standing on their island against the continent?
Yeah.
I'd like to see. I'm curious to see if this powers people like Le Pen in France.
Yeah.
That would actually really irritate some
It powers people like
leftist scumbags.
You know, yeah, it's going to bring people who are uglier than the people that they ever imagined they would ever see again.
Yep. If the EU can fall apart domino style, that'll be awesome.
You know, who said that? Victor Davis Hanson said that Europe has this bad habit of just going along until things get really ugly and then they turn very nasty. Maybe that's what we're seeing a replay of. But I think that Brexit is getting pushed away by the bureaucrats. I don't think there's any chance at all, or there's very little chance that they'll ever make that it's ever going to be real. You know.
What do you mean?
I think that they're gonna. I think it's very real that 2 years from now they'll adopt the euro.
I don't know.
Yeah.
I'm more optimistic.
Maybe because it was a surprise. It was a surprise that Brexit won. So.
And it's by 52 to 48, which means the left is going to say, "Oh, it's within the margin of error. It's not really significant. There's only 190,000 people plus their kids and their husbands who care about this. So let's just stay."
Yeah, right. Yeah, and they are already talking about the second referendum.
Yeah.
You know. Yeah.
And what is a referendum except it's just a suggestion to the government?
Really? It's not so the government can actually say no. Let's just disregard this.
Exactly. It's just it's not binding, and that's how government in Britain works. When the House of Commons makes some suggestion to the House of Lords, that's what it is. It's kind of like when our Congress sends a spending bill to the Senate. The Senate can then do whatever the fuck they want and pass it.
Yeah.
And
yeah,
so,
like.
Oh no, go ahead.
But I think the government will accept it because the Prime Minister of the UK is resigning, so that's a good sign.
You know when he's gonna resign?
I think he said in October.
Yeah.
Yeah.
Yeah. So just call me in October and buy me a beer, because I don't think he's leaving.
Oh yeah, well I hope he lives.
Well,
but yeah,
I doubt the UK is going to make it out. I think it's going to be an expensive bureaucratic boondoggle.
Yeah.
So sorry.
Yeah, like.
Yeah, go ahead.
Yeah, but also I think one of the things that might make other countries leave is that a lot of them are going bankrupt. You know, Spain is going bankrupt, Greece went bankrupt, and other countries are already showing signs of going bankrupt. Like Portugal, for example. Portugal is in bad shape right now. So I think that might change the the growth of the EU.
Well, let me just point out that in the late 1960s, Russia was having problems, and they bought some grain, and then it came to a real head in 1972, and they ended up buying like 20% of the American grain crop through secret agents out from under us. Excuse me, before we knew what was happening. And they had purchased this in a shipment all over the world to various different ports, and then to other ports, and eventually to their country, so that we wouldn't detect it. So they went on. That was the 1970s. They went on for another 20 years before it fell apart. Look at Venezuela.
Okay.
Venezuela is a more modern example, where they have been going bankrupt now for 10, 15, 20 years. Now they're getting to the point where there's no food on the shelves. So the European Union, on that trajectory, they are quite wealthy, and they will probably be able to slide very badly for another 10 to 20 years before there's sort of like real hunger where they're actually spending their real reserves to buy food.
Yeah. Yeah, and I guess we'll have to wait until the government reserves go bankrupt.
We might, I think what'll happen is it'll come to ethnic cleansing before that against the Muslims.
Yeah, maybe. Yeah. Well, I hope that they'll find a more peaceful solution. But if that has to happen, there will be like be like some kind of a civil war, right?
Yeah, it's a European civil war.
Yeah.
Now I don't speak about it as might be. I think it's happened.
It's already happening. Yeah.
Yeah.
Yeah, especially in places like Sweden, a bit of in the Netherlands, places like that. Yeah, places like that are pretty bad, and even it's kind of starting in Germany because of the immigration crisis.
Not from what I heard. From what I heard in Germany, it's been going for well over 10 years. A guy said that there are almost nightly street battles, pitched street battles between German white guys, whatever that is, and Muslims.
Oh, really? Wow.
And he said, we're used to it. People get hurt all the time. So these people, because I've done videos, they contact me, they write me and stuff. And according to what they say, there are pitched street battles that the police can't enforce anything against. Because what would the police do?
Yeah, I guess that would be a job for the military.
Yeah, and what kind of military do they have? So
they have, I think they have sort of like a weak military, and their leaders. I don't think their leaders would act on.
Here's the problem. Let's rewind just a little bit. I said the police don't come because what would the police do? And you say the military. The reason the police don't come is because there are two sides here. There are the white guys who really want to go home and drink beer and play video games and talk to their girlfriend. And there are the Muslims who want to come and rape the white guy's girlfriend.
Oh, okay, yeah.
So the white guys are going out in the street and saying, we are going to beat you down and kill you now in the street. And the Muslims are coming and saying, we're going to come rape your girlfriend. And so it's happening in the street. So if the police come, there's the political correctness stops them from doing anything real.
Wow.
So they can't. In fact, they've been saying, about the Muslim rape gangs in Birmingham and stuff. 1,300 little girls over the course of like 9 years raped.
That's a very sad news.
Well, the rape of Nanking is nothing. This is the rape of Europe.
Mm-hmm.
And what is a society that can't protect its women? What is that?
Yeah, it's like a society of cucks.
That's all men are good for, is to protect their women. Here's a hypothetical for you. Tomorrow, 95% of the men on the planet die of a mysterious virus.
Mm.
What happens?
It will be like everyone would be in deep poverty, I think. Nothing would be produced.
You're right, it would be very bad. But slightly ignoring the fact that no men are working in the fields and stuff, would we be able to make humans still?
I don't think so. Maybe they could get some sperm from sperm banks or something.
Well, it's a random virus, so it kills people randomly. So 5% of men are randomly distributed. I think that those 5% of men could be very, very lucky men. You see what I mean?
Yeah.
So let's now just put that in your pocket for a second. What if the opposite were true and 95% of women died of a virus tomorrow?
Yeah, I think humanity wouldn't be able to reproduce. At
How?
least it will take a long time for it to catch up because in a reproduction sense, women are more important because one guy can have lots of kids, but one woman cannot have lots of kids.
So just take 5% of males and make them get to work. But you can't take 5% of females and make them get to work. They get pregnant today, it's 9 months before they're done with that, and then they've got to raise the kid.
Yeah.
So you're right when you say that males aren't as important as females. That's why males go to war and males work out in the fields and females stay at home.
Yeah, exactly.
So there's a reason behind this shit. It's not just made up. It's not just that's just bullshit. There's a reason that females are more important. And we need
Social biology.
And the females, they know that.
Yeah. Well, we don't need to tell them that. Well, don't explain it to them. Fucking hell, don't tell them they're more important. Jesus.
Yeah.
87% of my viewers are male. So
Wow.
we can be careful about what we say here and be fairly confident that it won't get spread too far, you know?
Yeah, exactly. Yeah.
So, yeah, I don't know how we went from atoms and protons to Brexit to females, but we did it.
Yeah, exactly. You know, we went from AI, so AI led to Brexit and politics. You know.
Well, this is truly a philosophy hangout. There are no limits as long as you're not talking about sports.
Okay, yeah.
And you could talk about sex even, too, because I think we went over sperm and all kinds of stuff.
Yeah, reproduction and stuff. But okay, let's talk about sports, but in an indirect way. So why do you hate sports? Like in my case, I think sports is just like an entertainment show, nothing more. You know.
Yeah, people can do what they want with it. I understand that a lot of people like it. I understand a lot of people like to read fiction. That's fine. Well, here's the thing about sports that I think is cogent.
Mm.
Ancient Greeks loved sports, right? So I had to do some thinking on this. I had to think a little bit and say, is it okay for me to dismiss sports and say that's all shit, which I do really think and feel.
Yeah, especially the NFL and you know.
Yeah, given the NFL and the NBA and the choices I'm given today, yeah, I just couldn't give a fuck.
Yeah.
Ancient Greeks, if you take note of what is the nature of the Olympic Games they gave to us, they had no team sports.
Oh, okay, yeah. So it was basically just for the athletic aspect of it.
It was
right?
glory of
Yeah.
individual accomplishment.
Nice. Yeah. Yeah, like in my case, I play basketball, you know, as an exercise, but I used to watch NBA not for the teams, but sometimes for the players. You know, for example, I was like a big fan of the NBA when Michael Jordan was around, right? But nowadays, not so much. You know.
Well, yeah, I couldn't speak to that too much, but I can speak to the Super Bowl speech that I heard the year that Janet Jackson's nipple popped out.
Yeah.
The only Super Bowl speech that I've ever listened to, I have to say. In fact, the only Super Bowl I ever watched. And that night, I watched it for precarious reasons having to do with a very hot female that was available at that party. But I watched the Super Bowl, I saw his speech, and at the end of his speech, he said, I want to remind everybody that we did this as a team and no individual could have won this trophy. And I just, a wheel clicked in my head, and I saw that's what's wrong with sports. That's why I hate sports. And then later, studying it more, I saw the ancient Greeks didn't do that. The most team sort of thing they had was a relay race, where you could only win the race if all 7 of the relay people did really well. But other than that, it was all individual sports. It's all how far can Mike throw the discus, and how far can Joe throw the spear, and how far can Jill run in not Jill, they didn't have women weren't allowed. But Greek sports and Greek culture also give us a window onto why women maybe had not to be allowed out of the kitchen. It's not true. What about Ayn Rand? So I take it back, all you feminists.
Yeah, yeah, exactly. Yeah, yeah.
But-
I think there are a lot of ignorant women out there, but potentially women can do the same things that men do.
Yeah.
But there are a lot of ignorance because a lot of women, they depend a lot on their looks and not on their personalities and stuff like that.
You know why
So,
women aren't funny, and you know all that shtick.
say again?
You know all the shtick about why women aren't funny.
Yeah, I've heard that. Yeah, a lot of women aren't funny.
Well,
A lot of-
only men are funny. Only men are comedians.
Yeah, most of the time. Yeah, exactly. Yeah,
And then
and
that's
some women think
go ahead.
some
No.
women, some women think that men are clowns, and the better a clown a man is, the better date he is, right?
Yeah. They like a man that can make them laugh,
Yeah,
and usually the way to make them laugh is to play the idiot.
yeah, yeah, exactly. Like even the jerk.
Yeah, or the jerk, yeah. So what happens is men get manipulated by women who are, pardon me, women get manipulated by men who know what they want and just react to it. And then the women manipulate the men because of sex, and so it's fun. It's a back and forth. It's fun.
Yeah, yeah. At one time, I heard an actress. I think it was the actress that made the film the Black Swan. Portman, Natalie Portman. I think she said that after sex, the most fun thing to do is to lie.
Is to what?
To lie, to tell lies.
Terrible.
Yeah, so that's a girl I would like to be around.
Yeah, that's interesting.
Yeah, that after sex, what she finds the most fun is just be a liar.
That's
Yeah.
crazy.
Yeah,
Yeah, we've got to do something about feminism. That's all got to change at some point, I have to say.
yeah, especially the kind of feminism that we have today. Like I don't mind the type of feminism that started in the late 1800s. That that gave women equality under the law. You know that's all good, but now they're just want to exploit men. You know they're talking about feminism stuff, but they are turning into sexist. Everything they say is sexist.
Are you familiar with the idea that modern feminism was planted by the KGB in the 60s?
I'm not sure, but it looks suspicious.
It looks a little too plausible to dismiss, right?
Yeah.
Well, it is. The other day we talked about. The other week we talked about how the KGB they did like a small percentage of spy work, and the rest of it was devoted to convincing people in academia, right?
Yes, they
College
were
workers.
only in academia. Academia was like their main focus.
Right. Well, if you notice, feminism is emerged from critical theory, which is what is critical theory? That's the Frankfurt Schoolers, or what is called the cultural Marxists. So
Oh,
yeah,
okay.
of course, it's, you know, the idea that there was some KGB involvement wouldn't surprise me.
Yeah, not
It
at
is
all.
itself derived from a Marxist theory to begin with. So.
And one of the things that is really weird is that these so-called feminists, they defend Muslims. They defend the,
Well, that's
you know,
because Muslims are anti-West.
yeah, exactly. Yeah, yeah,
That's the
true.
whole point, is it's to attack the West.
Oh, yeah, exactly. Yeah, it's just another weapon to attack the Western culture.
Mm. So yeah, so of course, you know, you'd think, you know, what culture is more anti-feminist than Muslims? And yet they link together because, well, that's not the point. The point is it's a Trojan horse to attack the West.
The West, yeah. Yeah, and I think that this wave of feminism and and radical Islam, I think is that it can be at some time frame, it can be more dangerous than the great wars in the past. I think
Oh
I
yeah,
think
it way is. It's what was it? Can't remember the guy. It's a British neoconservative. Douglas Murray. He made a comment that cultural Marxism is much a war against the West as Stalinism and Nazism ever were. And it
yeah,
may be more
exactly.
dangerous because it's you know it's precisely because it's not an open front threat.
Yeah, it's more covert. It's sort of like a guerrilla type of attack, right?
Mm-hmm. Yeah.
Now, we faced that sort of a threat under communism in the 50s and 60s in America. Under McCarthyism, it was sort of like a reaction to that.
We should have had more McCarthy. If there was more McCarthyism, we would never have had the 60s.
Yeah, exactly. Now,
We had like 100 times more McCarthyism. That would have taken care of the problem.
so what if like Islamophobia of the 2000s should have gone into turbo, but it didn't? Therefore, we're facing what we're facing now.
Mm.
And so in the year 2045, we're going to have a huge motherfuck off war against Islam, the way we don't need to and shouldn't if we could take care of the problems right now instead of...
Yeah. Well, hopefully things can be turned around. For example, maybe if Trump wins, he will, tackle it. Maybe things can get better.
Yeah, I hope Trump will be good.
Yeah, yeah,
He'll just be a ninny, but I hope he'll be good.
yeah. I don't have high hopes, but at least it's something.
He's much better than the other fucking, 17 people he ran against on that stage? Or 18? How many other Republicans are he started out against? 22?
Well, I will say I did like Marco Rubio, but we'll see how this goes.
It's fine.
It doesn't matter now because he's the nominee, so,
Yeah, that's the thing, is like, people say Trump is terrible and how can this happen? Well, let's just point to the fact that we didn't choose between 2 or 3 people. We chose between nearly 20.
They should not. What were they all doing running at once? It was so stupid.
They were giving America the choice America wanted to try to have.
Right, but I mean, the Democrats only have, 3 people running, right? Like, you can't have...
Oh, the Democrats are...
If you want a decent...
3.
What?
We were lucky to have 3 Democrats running. They're communists.
Right, I know, but what I'm saying is that enables a front runner to consolidate the vote ahead of time, earlier down the line, right? And you have, a party with a whole bunch of nominees or a whole bunch of candidates running. They can't consolidate the vote early enough, and then you end up with, maybe not the best candidate, depending on how the field was played. It becomes more of a game of survivor.
You think
that's a game of...
You think Donald Trump's victory was slightly a matter of bad tactics?
Yeah, and that kind of bad tactics on the part of the, there were 20, not... Rick Santorum knew no way he was going to win. Not either the nomination nor the presidency, even if he got there. He should not have been in there. Cruz, probably the same, not quite that level, but, there are certain candidates that they should know that if they've been running before, they should know that it was not going to work. You know what I'm saying?
Yeah, but okay.
Rand Paul, probably the same thing. He's
Okay, well, Rand Paul and Cruz are hard targets for you to pick at when you've got so many other candidates who started out trying.
right. What I'm getting at was when they all try together, it kind of messes up the process because it's hard for there to be a decent front runner, and you can have. I mean, like, I don't think Trump actually won with a plurality. He didn't win with a majority. He won with a plurality, and the reason he was able to do it was because by the time that people realized we have to pick someone other than Trump, he already had enough of the delegates that it was too late.
All right, you don't propose an alternate system such as the Democrats, where they only had 2 or 3 people.
No, what I'm saying is that some of the candidates should have shown more prudence for like the well-being of the party and the country.
So you want some balance between 2 and 3 and 20.
Yeah, exactly. I don't think that I don't think it even should be like something like some kind of party rules, right? I don't think that's appropriate. But what I'm saying is, at a personal level, they should have gotten their egos out of the way, and instead of like running for the sake of running, just being like, I don't stand a chance. I don't want to ruin it for some other guy who does stand a chance, who might be a better candidate.
Well, I have to say I side with the mob on this one, and I love the fact that 20 of them thought they'll throw their hat in the ring and see where it goes, and that's sort of the magic of what makes America great. And
right. I know. Well, what I'm saying is, you're running for president. I mean, it's not like you kind of have a responsibility. You're not doing it. You're not supposed to be doing it for yourself. You're supposed to be doing it for the well-being of the country in a way.
Yeah, and
it's not just running for president.
And let's just imagine that there's only people who are running for the well-being of the country, and they're all dickheads. And somebody comes along who's a cowboy who's doing it for himself, and he actually has some good ideas.
Yeah, that does happen. That does happen too. But what I'm saying is, that's not always the way that it is. Like it's not supposed to be just something that you.
Well,
you have 20 cowboys. When you have 20 cowboys,
I'd rather have more cowboys than less.
Right. What my problem is I have to see the situation where we have, as a result, it ended up giving us a weaker candidate to match off against Hillary with.
Weaker? You think Donald Trump's weaker? They had.
Well, I hope he pulls his polls out. I hope he pulls his polls out. I'm all for him now that he won the nomination, but I do hope that he pulls his.
Well, at least the other Republicans. I don't think the other Republicans will vote for Hillary. They will vote.
Yeah.
They'll vote for Trump.
Those people that really piss me off. The never Trump people really piss me off. I was for Rubio in the nomination until he pulled out. But if you're gonna go that far that you'd rather vote for Hillary to keep Trump out, then you've got your priorities all upside down. It's just give me a break.
Well, it doesn't matter what happens here because Europe is the real show. So what matters is how our president deals with Europe.
Now, I want to hear something cool. You guys know who Katrina Pearson is?
No.
Say again?
Katrina Pearson.
No.
What's with her?
She's Donald Trump's national spokeswoman.
Uh-huh.
I'm friends with her on Facebook, and we talk sometimes.
I heard she's a hoe.
Yeah, I don't know. I'm not gonna touch that whole thing.
Oh, do you know her? You
I know her. Yeah, I know her. She's actually a quantum idealist. She watches my videos.
Oh, okay.
And she says she wants to help put them on Fox News. So.
And she knows Trump?
And she's not just knows Trump. She's Trump's national spokeswoman.
Oh well, you've just destroyed my confidence in Trump.
Why?
Because she believes in quantum mechanics.
Not just quantum mechanics, quantum idealism.
Same.
Oh, okay.
Same.
Yeah,
it's a mental matrix simulation.
Disaster.
Yeah. That's what's in fashion nowadays.
Well,
that the universe is a simulation.
Yeah, the crazy thing about it is, I was actually the one. I was having fun. I realized there were philosophical implications for quantum mechanics, specifically along the lines of idealism. I thought it'd be fun to kind of put my hat in the ring, so to speak, and start trolling people with this. And next thing you know, I have this movement behind me. I'm like, what? I didn't intend this. I was doing this out of my parents' basement. And next thing you know, it's it turns into a career. I'm like, holy cow.
Well, you're driving in reverse. You didn't do what you said you got. You derived quantum meaning from quantum mechanics or vice versa. No, you have your shit in reverse. Because you can't go from quantum mechanics to reality.
Well, quantum mechanics is the best theory they have of reality. It's the most accurate theory they have of reality. It's what,
No.
Really,
so it makes your computer run. It makes what your phone run.
No, we know about reality. We know about reality. We're learning about
quantum mechanics. Quantum mechanics right now is just a tool. It's just like epic cycles. It doesn't explain anything. It's just like a carpenter tool. That's it.
Well, no, some interpretations are like that. Yeah,
It's
but I mean,
statistics. It's only statistics. That's all it is.
Yeah.
No.
it's more than statistics. I mean, we know certain things about it.
Right. So have you heard of the pilot wave, of the bouncing?
Yes, I have. I have. The problem is that it doesn't fit with the non-locality issue.
Non-locality. It does.
It requires faster than light signals to pull that off.
No, well, it just requires a wave function.
Right. What I'm saying is that's nice if it in a local setting, like say you might replicate double slit and so on. But what it won't replicate are a couple experiments that it will not replicate are the Bell test and the Koch-Inspector test.
Well, I'm not sure about the Bell test, but there it's promising. The walking droplets.
Well, no, what I'm saying it's there may be an element of promise insofar as you can model waves as wave functions, but it's not going to be anything more than probability waves. Those are not going to be those waves that they're modeling it with are not going to be determinate waves. So yes, there will be. If you model the, I mean, it's natural that there's going to be a connection between wave mechanics and quantum mechanics because quantum mechanics deals with what? Probability waves, right? So of course you're going to see a connection. But what I'm saying is it's not going to. You treat those waves as physically real waves in space time.
Yeah.
Well, it's going to contradict some of the predictions we see in quantum mechanics, or some of the actual experimental data in quantum mechanics.
I don't think so. I think a lot of the the thing is that a lot of the phenomena in quantum mechanics it's emulated with walking droplets, So
right.
So
what I'm saying though is that you know what entanglement is. We talked about that the other day, I think. I mean, me and Mr. Crawford, I don't know who else was in the hangout.
Yes.
Okay, so my point is that when those two particles are at vast distances from one another, right?
Yeah.
They need
like
to...
the polarity of photons.
There's going to need to be some kind of signal that goes between them to actually make sense of that. It's not just a matter of, them...
To make sense of what?
To make sense of... Because you change one... You change one, you measure one, the other one suddenly goes from particle to wave and takes on the opposite state.
Well,
instantly, miles, many millions of miles away.
Yeah, but that could be that could be faster than light signaling.
Yeah,
right, but that's ruled out though.
No. You don't have to assume that the node is that many million miles long. The node that connects them may be much shorter.
Even like a hyperspace node.
Like another dimension that is simply connected to everything, but only comes into effect under certain conditions.
That sounds kind of like what they're going on with emergent spacetime.
Well, I don't know if you want to do something with it or not, but Stephen Wolfram proposed that nodes of go ahead. If you understand what I'm saying, go ahead.
Right. Well, they are
for example, transverse waves travel at the speed of light, but for example, scalar waves could travel, at the FTL speeds.
Right, but those aren't really. What's the way to describe it? It's not transmitting information in those waves. It's kind of like a wave at a. When you go to like the football or baseball game or something, and everyone's doing that big wave across the crowd.
Mm-hmm.
It's there's no actual wave moving, but it's a, how can I put this?
I get your
You
point.
see what I'm
like,
you see what I'm getting at.
Yes.
That's the kind of wave. When they talk about like phase velocities that are going at like 200 times faster than light and so on, that's what's going on. It's not really anything parabola. It's a
Yeah, I agree. A wave is just the transmission of motion. The particles themselves are not moving.
right. Then there is the Koch and Specker theorem test, which is even more difficult to explain, and that is you guys have heard. You remember the 3 cups in a ball trick at the circus, right?
Yeah.
Where you try and pick which one the cup is under, and the ball is not under whichever cup you pick, no matter how many times you pick it. And of course, that's done by a sleight of hand at the circus. However, there's an actual quantum mechanical version of this that deals with it's set up by contextuality, and when you have the particle has like one of 3 possible states, right? Like polarizations. And the thing is that if the polarization was real beforehand, okay, at a real value beforehand, then when you pick it at random, it should pick, there should be at least a 1 in 3 chance, a 1/3 chance of it being one of those states that you picked, beforehand, right?
Okay.
The problem is that when they do the experiment, it turns out that you get it none of the time. If you pick it and you set your, context up to measure it like that, it never ends up on, say it was red, yellow, and blue or whatever. It never ends up. Pick it's red. It never ends up a red, no matter how many times you do it. Even though
because
it was real beforehand, it should have ended up red at least a third of the time.
Yeah, but the thing is that as you pick one, the wave function collapses, so you don't have what you had before you checked which one of the states was on.
Is this the case of the measurement changes the phenomenon?
Yes.
Yeah, let me. There's another one.
It has to be. I have to say that this has to be a philosophically mistaken experiment.
Well, it's not that it's philosophically mistaken. It's just that the fundamental nature of reality is information theoretic rather than.
You're never allowed to say that ever.
That's what you think, but you think that we create information and that it's not actually something fundamental to the world, right?
Then your experiment has either been deceptively worded or inconvincingly organized, or several other devious things could have happened.
There's no reason that rules out something like an information theoretic model of the universe on theoretic grounds.
Of identity and reality.
There's no, it doesn't. Those things don't rule it out either.
Yes, they do. Even though they fit within your theory doesn't fit within them, and that's the real problem.
No. It's just simply that there is a reality, and it does fit with identity. And the thing is that the reality is simply made of information. So reality exists. Reality is made of information. So saying reality exists is the same as saying that the world, in that case, that reality is information, and then of course it's identical with itself.
So you are saying that our minds are creating that information? Is that what
No, it's external information that we're interacting with.
Oh yeah. So, but for
like the computer game analogy, right?
Okay, yeah.
I had Trevor on the other day when he's talking about the whole you're interacting with the exterior game type of thing.
Mm-hmm.
Yeah,
It's a reality there. It's a reality there. It's not just us making it up in our minds, but what it is not what we think it is. It's
everything is reality. There is no everything is information.
Well,
everything's information. There is no reality.
Well,
reality is information.
As long as we can tell, we're living in a real world, in a real universe. You can try to say that we live in a simulation, or maybe we live inside a cage, or whatever. But those things are far off. Those things.
They actually tested this 2007 in Legacy very directly that specific aspect, because they said that the system, in order to fit quantum mechanics, the predictions of quantum mechanics, has to either violate locality or reality, or realism in the sense that they're being physical realism. Right? There is a reality beneath it, but a physical realism in the sense of simulation versus not. And so what they were saying is, and I'm using simulation in a broad sense, meaning it doesn't have to be an actual like matrix simulation with like robots running around outside or anything like that. It's information theoretic model of the universe, whether it's.
So how do you define?
Anyway, what they did was they falsified, they ruled out locality. Then they had an additional test that was the Bell's inequalities back in their test in 1982. Then in 2007, Zeilinger and his team, Marcus Aspelmeyer and the number of people in the experiment, they tested another one called Leggett's inequalities, which was ruling out. It was the last degree of freedom left over to study for non-local hidden variables. And so the cool thing with this one is that even if you have FDL speeds, this ruled out non-local hidden variables as well. And so because of this, you look this up on Nature, it says physicists bid farewell to reality, and quantum mechanics just got stranger.
Listen, Rats, I've been listening to this now for 120 seconds, so I can't even remember what you started on. Are you kidding me? What was your point?
That reality is information theoretic.
Oh my God, okay, if reality is information, let me just give you a clue. Information is a concept that occurs to us when we observe reality.
Yeah.
Yes, that's also correct. And,
So,
no, hold on. That is correct. And take that fact.
Cheese and rice, how do you switch them around?
No, hold on here. Okay, you said that reality is well, it doesn't have to occur to us. It can occur to any mind, right?
Reality here exists.
Okay, as information.
Inside of reality, we conceive of information.
Our minds do. Okay, so minds in general conceive of information. All right.
And what gives us information is the outside world, is the physical world that gives us information.
Assuming that that is
not
actually information to begin with.
No assumptions. There are no assumptions needed. That's where our information comes from. Via
Okay, sense perceptions, right? All we have is sense perceptions. Now, you could go on the Kantian route, which I'm not going to go there.
Not only sense perception.
Hold on, I'm not going to go down the Kantian route, but what I'm going to go down is a different route. Okay, Kant said we can't know what's beyond our sense perceptions, and that's nonsense, and we all agree on that. But there is a way we can go a different. We can go ask the same question Kant asked, and then go a different direction instead, and say, we stop at our sense perceptions, but then we have to deduce beyond that to, solve the problem of induction, the evil genius of the problem from Descartes, and get around to how can we know from our senses to reality. And the way you do that is you say, you have your sense perceptions, those are actual things, have their own ontic reality, and because the interaction problem rules out substance dualism.
Wait. The interaction problem rules out substance dualism. Put that in parentheses and cut that out because that's absolutely loaded. Now, if you can complete your thought by setting that aside, that's
substance.
Well, okay. Well, then we have to discuss the interaction problem because it's a very direct step. It's a very what I'm going
to set that aside, or else I'm going to accuse you of just obfuscating.
No, I can. We can talk about that. Okay, we can talk about the interaction problem and why it logically follows and so on.
All right, I hereby accuse you of obfuscation.
No, obfuscating. It's a. I mean, most people, I would assume most objectivists would even accept that dualism is false, right? Like the notion of a ghost soul inside of a body or something, right? You would reject that, right?
Fucking kidding me?
You would reject that. I mean, you would agree that is false. The notion that there is like ghost stuff and there's matter, right?
Ladies and gentlemen.
No, not really.
Really?
No, like for example, the mind is it's a function of our brain. It's not a different. It's not a.
Okay, so you would not say it's a. So you would reject dualism as well, then, am I right?
Yeah, exactly. I think.
Okay, good. So so whether or not we use the interaction problem to get rid of it, we can all agree that dualism is false, correct?
Yeah.
Okay, therefore, it follows that since sensory information is one substance and dualism is false, no other substance can exist.
That way, sensory information is not a substance.
Well, it has an optic reality, or we wouldn't be seeing it.
Sensory information is a process.
I don't know. It doesn't look like a process. Is something that moves, and also a process is something. In order to conceive of a process, you have to conceive of a processor, right?
Well, if you want to go really, really basic, it's a node of updatement during time, but that's too abstract.
Okay. Well,
Rod, I think I recognize your ideology here. It's what was called idealism in the Enlightenment era.
Right, that's why it's called quantum idealism. The model actually is. It was kind of cool because I had contacted a scientist named from the University of California, Irvine, Hoffman, and he actually agrees with my approach. And he's making a physicalistic model of, well, you can call it physicalistic. I don't even know what that word means anymore at that point. But it's a scientific model of idealism that's based on cutting-edge quantum gravity with cognitive science.
Yeah, but at the time, say in the Middle Ages, instead of saying that everything was a computer simulation, they were saying that everything was made up by God. You know,
Yeah.
It's a mental simulation, so it's a computer in a sense that it does computations, but it's not actually.
Good point. He makes a very good point. How do you distinguish between your mental masturbation and the mental masturbation of the monks?
Well, my one is scientifically sophisticated, but it reaches the same conclusion.
Well, not really. Well,
It's quantum
I tell you what. Back in those days, they were very sophisticated too. They had like very intricate, theories and stuff based on God, based on the nature of ideas.
Okay, the difference between this one and their one is that this one can actually be tested, and I would argue that based on the data that I have, it has.
I haven't seen that data.
Okay, I can get you the papers. I actually emailed Stuart Hameroff on one of the pieces of evidence. The two other pieces are the Bell inequality test in 1982.
You say philosophically sophisticated, and you begin.
No, scientifically sophisticated.
Well, scientifically sophisticated, you begin premise number one by stating the primacy of consciousness, which is absolutely untrue in our universe. The primacy of consciousness.
The evidence has proven the science has actually proven that, though. That's
the primacy of consciousness fails.
The Bell's inequality just proves that there might be transmission of information that is faster than the speed of light. It doesn't show that.
Ruled out by relativity. Well, that's actually not why I brought Bell's inequality in. I was going to list 4 experiments that, when combined, prove idealism.
Well,
Bell's inequality test is only one of the 4.
Information you don't have doesn't prove anything. So when you say something's not observed and therefore you draw a conclusion from it, that does not give you any grounds for a conclusion. You don't know what happened when you didn't observe it. When you say that
you can, when you can rule certain things out. Like, for example, we know things don't go faster than light, and we also know that these pairs are separated.
It's not proven that things cannot go faster than light.
Well, that's relativity. That's Michael Simoni's experiment proved that back then.
No.
However, we don't even need that now to solve this, because we have the Leggett inequality test, which the reason I brought Bell's inequalities was not to prove non-realism. That's what the Leggett inequalities do, and those do it even if there are FDL signals. Okay. The reason I brought Bell's inequalities in was when you combine it with Leggett's inequalities.
Can I just interrupt for 1 second? I just want to give you if there was a plasma of nonsense and an event started at one point, and that particular node was connected to all future nodes, then we would be able to allow.
Hold on, quiet. Ellen, you say something?
Me?
Sorry, I had to talk to someone for a moment. I took my headphones off for a moment.
Okay, so let me just imagine a situation where there was a plasma of some description we can't imagine, and an event started at a particular node that spread outward, and that outward these nodes were bubbles of a certain kind, but they were all connected to the central node in some way, and the central node was connected to every other node.
Like wormholes.
The nodes themselves were only connected to each other, except for their connection to the central node. Now that could allow for entanglement, because we've got our four nodes, which are...
Wouldn't that kind of undermine the notion of space as we know it, though?
We've got our fifth node, which is space-time plasma.
Okay, well, that's actually interesting, because one of the ideas being bandied around in quantum gravity is that entanglement generates wormhole geometries, and that it's actually nodes of information underneath space-time linking things together.
Well, it doesn't have to be underneath or behind space-time. It can be in the nature and fabric of reality and part of the evolution.
Well, the thing is that when you do that, Renate Lal pointed this out when she...
the problem is when we do that, we do away with all gremlins and gods, which you want to do. You want gremlins and stuff. I can do all this stuff. I can do entanglement with the laws of the universe, and I can still go to the...
more parsimony, vastly more parsimony.
If we go down your route, I can't go to the theater and eat popcorn because that's all imaginary. But if we take
you eat popcorn, but the popcorn, there is still popcorn, but what we call popcorn is not what we thought it was before.
Exactly, but if we take my route, you can still have real popcorn.
Well, it depends what you mean by real, right?
Yes, it does, and I'm not trying to cheat anybody. I'm not putting cheap, fat-free shit.
Well, it has the exact same properties that we would associate with matter, but now it's attributed to information or ideas.
Hey, but you're a commercial salesman, and you're trying to sell me fat-free shit to say it's got the same properties. It doesn't. Reality is...
It does. Physically, it does all the same properties.
Listen, I can update nodes of reality that were interactive from the beginning of the Big Bang. There's no reason that I have to disconnect them if it all comes from a central point. I can allow them to remain connected without it.
Hello?
If it all comes from a central point, I can allow those central points to remain connected in some way. I can do it without putting a magical hat on because we have the evidence of the redshift. So I can do that without putting a magic hat on. I can connect all my central points. I can do space, time, and get your fifth dimension, whatever you want to do with entanglement. I've got all that in my pocket. And I still don't have to go with the total information processing. I don't have to do any of your fancy shit.
Okay.
It's just that that information has to be transmitted in some way, you know. And,
yes,
and information...
The way that it's transmitted is tangled up in some way to the original...
This guy has a blog from a physicist friend of mine. One second here. And he's going to point out a problem with where's the share option?
Can I let Super Fin guy talk for a second?
Go. Is there real fast? So is there a share option on like a side chat on the Google Plus?
You should have a menu at your far left that allows you to share screen.
Oh, I see it.
Yeah.
Go ahead and do that and let Super Fin guy talk. Super Fin guy,
go ahead.
What you need to say?
Well, I was saying that information it's a concept. It's not a thing. Like if you say that we have
I would say a concept
a universe of
thing.
Say again?
I would say see the thing is we had a discussion with Mr. Crawford and myself the other day. I would say that a concept is a thing as well.
Well, I don't believe that. That's
I know that's our. We have to talk about that later, I guess. But
he grants ontology to concepts. And for you and I, Super Fin guy, if I could say for you and I, a concept, probably an organization of sense information is probably how I grant.
Exactly.
By the way, I thought something.
It's a relationship in nature.
Well,
I wanted to bring this up.
It's a relationship inside our mind of noticing what nature is.
Exactly.
I wanted to bring this up to Mr. Cropper because this is kind of an interesting point. Was the other day, you had that model of the mind where you thought the mind was just sensory data, right?
Yes, now you probably saw my comments and stuff. I realized that it's slightly more than that, but I was trying to not give you too much ground. However, if you want me to defend that, I think I'm on very strong grounds there.
Well, what I was going to say was I was actually going to play devil's advocate on that as well, believe it or not. And I was actually going to give you that I'm going to show you something really cool you can do with that. Let's just suppose that it's just sensory data, okay? Now, in my model, I'll include, there may be ideas inside, there may be an eye.
Now, you've already gone a step too far. I didn't say it's just sensory data. Now you...
Okay. You can add additional things in. You would say that it is information, right? Your mind?
Yeah, like for example, like the problem of how we perceive color. For example, there are some people that perceive color differently. Say they could perceive a red stripe as a blue stripe,
Right.
but that is how.
Inversion.
Yes,
Well,
but that is how the mind interprets it. Just like a computer, we have a code for certain colors, and sometimes that can go wrong.
Finn guy, I don't know if you heard our discussion the other night, but it's about sensory deprivation tanks and how if you are cut off from sensory information, you quickly go insane.
Yeah, because of the brain. Yeah, because the brain can take it.
Okay, if you're aware.
I had a thought that I wanted to expand on that, and I didn't fully agree with the notion that it was there was more to it than just the sensory data, but I was thinking, let's take that on board anyway, and I'll show you something that I realized that whether or not you go your approach or you go my approach and you say there's more to it, there's other ideas as well, and platonic forms and an I and so on, whichever route you go on that, both accounts would agree that it is actually just integrated information of one kind or another. You'll agree there? I mean, it's information connected together in a single conscious experience.
Integrated by what and how is very important, but I'm sure
right.
We
can get to that later.
It's information and knowledge.
Yeah. Why do you say information and why do you say it's perception? I'm an entity. That's how I perceive. That's my knowledge comes from the fact of my nature. So you just skip over it. You just want to say there's information.
We'll get to that later. Okay? But what I'm saying is just now let's focus on this particular part, okay?
No, I think you have to get to it first. I think if you start with that, you could skip over all your nonsense and marshmallows.
Well, the problem is if we go to that one, then we go to premise one, and you're not going to like where premise one goes because we're going to look at what we are as a being, and then I'm going to bring up, well, you're a collection of cells which reduce to atoms, which then reduce to subatomic particles, and then we apply those nasty quantum non-realism things to the subatomic particles and say you as an entity is a quantum computer program.
I have the tools to deal with that. You don't. So
I do too, actually. That's the thing. I know the physics a lot better here than you guys think. I know better than you do, actually.
I know what physics is.
Well, I know my fair share of physics.
Okay, but let's just look at the cognitive science.
I know that the subatomic particle, you have the electric fields, like the wave functions. They interact in a way differently than in the macro world. So I think that's the difference between the
actually, that was falsified as well by the test of the Leggett-Gargan. The hypothesis you're talking about is called macro realism, and that was also falsified in 2011 by tests of the Leggett-Gargan equality.
What do you mean?
Well, I would have to see the the
Let me
evidence
dig it
for
up
that.
for you. Hold on here.
Let's see it.
I mean, not just a paper, but the actual reasoning and real evidence for that. Because nowadays, a lot of scientists they peer review themselves, and they basically live in a circle jerk, and so nowadays peer reviews are not that reliable.
Then it sounds like you're going down the road of postmodern. There's no reason that you should be able to go. There's no reason that quantum mechanics should just stop at one level. Now, it is true that you're not going to see your car quantum tunnel through the garage door or anything like that. But the fact of it is that the rules, the reason for that is that when you go at a very high level in quantum mechanics, the the probability densities, shrink down to reach a classical limit, and so of course it's going to behave approximately classical at a classical scale.
Yeah.
That doesn't mean, however, that principles of quantum mechanics like non-realism and so on apply to us. Is that they are not very noticeable. Example I gave.
Yeah, I agree. I agree. Like for example,
Neo.
Molecules are ruled by the quantum mechanical principles.
Right.
You have the
What I was getting at is, I use this as an example in one of my videos and some of my talks where there's this little trailer for the second Matrix movie, and Neo was booting into the Matrix, right? And you see this little clip, I froze it, where he's, half booted in, and he's still, you can see the information stream, right? Now, the point is that in the Matrix, it's simulating a classical world. You don't see, for the most of the time, you don't see weird quantum mechanical effects. It's a classical world, behaves classical. You push a wall, it's hard, you can't quantum tunnel through your garage door and so on. But then if you take a magnifying glass on, Neo, and you zoom down with your microscope, you're going to see that it's, little green matrix code way at the bottom. And then at that level, the little green matrix code, you're going to find little weird quantum mechanical effects based on that information processing.
No, but I would say that the quantum mechanics of mechanical effects are occurring. Yeah, I agree that they occur in the microscopic world as well.
What I'm saying is,
but they form the matter that we see. The molecules arranged in certain ways, the atoms arranged in certain ways to form the mass. But at the subatomic particles, we see sort of like a different kind of behavior because we have the predominance in the in the motional particles, the predominance of wave functions. That's where the difference is.
Can I ask if let me just do an analogy and see what you two think of an analogy I would like to draw.
Let me insert one thing. Like for example, if you were capable of making like a wave function big enough to affect macroscopic matter, it would be possible. But that does not prove in any way that the world is informational simulation. It just shows that.
So what I'm saying is, even if macro realism were true, it wouldn't really matter because the macro world is made up of lots and lots of micro world.
All right, can I just insert an analogy and see what you two think of this analogy?
Go ahead.
Because I think this absorbs everything you guys have been saying, and I've been waiting and making sure to say I'm not just throwing a left ball here. But what if it is the case that what we call quantum mechanics is studying what is sort of, let's look at the sun as an atom, and that's the solar system around the sun as the environment around an atom, and quantum mechanics is studying meteorites hitting the planets.
Yeah. Basically, it's just a collection of observations.
Yes.
Ensemble interpretation. The reason that it looks random is because realistically we can't tell when the next meteorite's going to hit. We can kind of tell probabilistically, but we can't tell.
Well, I think. Well, yeah, you cannot tell because if you interfere with the wave function, it will collapse. But we can know how, for example, if we engineer, for example, a wave function, we know how the particles in that wave will behave. So we can know that way, but we cannot know any particular particle, like just to know its position. We have to know what the wave function is doing.
So if we do funny things with an enormous laser beam, we do funny things to a solar system, we can predict what it will do, but if we just watch it, we're not sure what it will do. Is that an analogy I can draw?
Not quite. The reason that the meteorite thing, I want to go back to the meteorite thing for a second.
Yeah.
The reason it doesn't work is they actually had an interpretation like that at one point. It was called the ensemble interpretation. They said that you know, when they saw those waves, when they tried the double slit experiment with the electrons, and they see these waves in the back wall, they figure, well, maybe the electrons are bouncing off each other in a wave-like fashion, just like, you know, water waves. You see, you know, water waves on a wall. Well, it's not really, you know, you think the water molecules are not really water waves. It's actually just the waves are made of a collection of water particles, right? So they thought that maybe the electrons are doing something similar to that, right? So what they did is they fired a single electron through at an electron gun that was able to send a single electron through at once, and they shot it, and it, you know, made a little splotch on the screen, like you expect a particle to, and they shot another one, and they do that again. They do this for an hour.
Yeah.
You know, splotch, splotch, splotch. After they were done, it turned to a pointillized image of an interference pattern, even though those electrons had no other electrons to interfere with.
Yeah, but it had the wave function to interfere with. Like
Well, it was in the state of the wave function. That's the thing.
I'm not sure that disproves what you say it disproves.
Well, that only rules out one interpretation.
The thing is that the electron, it's not a naked particle. It has a wave. It generates a wave, and the interference of its wave, it interferes with its own wave.
Well, it's a wave.
So that it creates that pattern.
It is a wave when you're not looking at it, right? It's a wave of location, you know, probability wave of locations when you're not looking at it. When you do look at it, then it becomes, it's a single particle in a single location with, you know, like a billiard ball.
Yeah, but the thing, an electron is not that, you know. It interacts with a wave. So that's why we have pattern.
Well, it's not that it interacts with a wave. It is a wave when you're not looking at it. That's the whole point.
Now, when you say, excuse me, when you're not looking at it, blah, 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 that's a very strange sentence in my ear.
Right, that's what they've seen. It's called, you know, the famous collapse of the wave function / observer effect, right?
You're telling me what happens when you look at it, and then you give me more evidence about what happens when you're not looking at it, and that's very strange to me.
Well, because you can tell how it. I mean, obviously, it creates an interference pattern, right?
So
you weren't looking at it. You weren't looking at it when it goes to the slits. Nevertheless, even though
what I'm hearing is you're saying when I interfere with it, it does this, and when I don't interfere with it, it does that.
Well, you can deduce what it was doing when you weren't looking at it based on, you know, it creates an interference pattern on the wall, and it behaves exactly like. It produces results that behave exactly as though it were a wave. Okay, and so there's
you say when you're not interfering with
or a wave, or like it's riding a wave, like it has a pilot wave.
Well, remember the whole pilot wave thing belongs to a Bohmian model, which doesn't fit relativity, and then also furthermore, I gave you the link on the side.
Super Fin guy, do you know?
Oh, okay.
Yeah, okay. Here it says, the reference frame. Here's the explanation for it.
I just want to ask.
I'll say that out. But I think
you know about David Bohm, and
he's got it into.
No, I want to ask
partially right.
if he knows about it.
Yeah, I've heard about him.
Do you know I did a 8-part video series back when they were 10-minute videos, so it's like an hour and 20 minutes about it?
I actually watched those. I remember those way back.
I think I've seen them, but I don't think I watched all of them.
Let me remind you, because I can just give it to you very quickly.
Okay.
He says that it's like a ship in the ocean where it looks like it's changing, where the waves around the ship are the water carrying energy. It looks like when it changes directions that's very strange, but there's actually radio waves that came to its CB that told it to change its direction. So when we look at particles, we're sort of looking at them saying, how did it get that information? And there's sort of this other thing like a radio wave or something.
That we're not seeing, right? Okay, so now here's the thing. This is actually ties directly into the article I was about to cite. It's called All Realistic Interpretations Falsified by Low Heat Capacity. So now, let's suppose that those additional waves were there telling what to do, right? We're not looking, that we're not seeing. Okay, those would carry more information, right? That we're not privy to at that point. It's hidden variables, right? Okay, if that was there, when you have information increase, it increases the number of states in the system as well, right?
Well, you could say that it increases the order, because now the particle has to walk a certain
All right.
path,
Okay,
not not
what I'm
not.
getting at, what I'm getting at is whenever there's an increase in information content, there's also an increase in entropy, right?
Yeah, that's what I was getting at. I don't think it's an increase in entropy, because
So
the
I
wave
mean,
function.
it's not an increase in entropy itself, but it would correlate to that, right? I mean, like on its own, that's not the effect it has on the particle,
Oh,
but
can
on
I
its own,
can I
wherever there's
parentheses around that? Does an increase in entropy mean an increase in information?
yes.
Not really,
Well, it's an increase in the number of possible
because
states, which is
sometimes you increase the number of states, you just increase the number of states. But if you have a certain path, or you have a certain state that the particle can have, then you decrease the number of states, because you know exactly what are the states that are possible when you don't have a wave function.
Pardon me.
So I get your point, that you're talking about heat capacity, and how
yes.
heat increases entropy.
So it'll create a higher heat capacity, but if there are these hidden variables there, there will be a naturally higher heat capacity than we see. We don't see that heat capacity. It would manifest. Like what's a good example? There's some of these stories about lake monsters, right? And they're able to falsify some of these in some cases by saying, if we would see this, we see this ecosystem, and we would see, if it has to eat, this lake monster has to eat fish to survive, right? Well, we've accounted for all the predators here, and they're eating the number of fish that we see, and well, the number of fish stay constant for what we would expect for the actual predators in the lake to be, and so there's no additional predator that's, now if we did see, for example, that for some reason there was this huge deficit of fish there, right? That a whole bunch of fish were being eaten, and we didn't know. Well, the alligators only had there's only so many alligators in the lake. They only ate this. But there's only so many anacondas in the lake. They only ate that many. Only so many sharks in the lake. But that's not enough to eat all these fish that are being eaten. Where all the fish, there's a big chunk of fish that are being eaten. Then we have, reason to believe there's a lake monster, right? So the point is that you can kind of tell there's not something there if you can account for where all the fish have gone, right? So the analogy here is that we would be, if these hidden variables or lake monsters existed, we would be seeing the effect of it showing up in the heat capacity, and we don't.
Yeah, but I don't think that wave functions would increase the heat. I don't.
Well, if
I
they
don't.
increase the information content, they would increase the heat capacity.
Well, yeah, but maybe that's not the case. I don't think
Well,
that's.
that would naturally follow. I mean, like it's when you have increased information content, there's increased number of differences, and well, differences
No.
what? That's just what information is in physics, is a measure of differences. And you ask differences of what? Well, they're different states. And so
But
it's an increase in states. Increase in information equals increase in differences equals increase in states to have those differences.
But say, for example, there were no pilot waves. I think that would be a situation where you will have more states. You'd have more entropy in that case. If
More
you have
entropy.
like a specified path that the that the that the particle takes, then you have less states. So I don't see how that implies.
Well, no, because you don't need the particle to have other places to be beforehand. That's the whole point. It's not that it's not. It doesn't have to compute all the possibilities in the wave function if the particle is non-real to begin with.
Oh, come on.
Oh, okay.
Well, that's where it's going.
But
That's where all the evidence is pointing in this direction very
Oh,
solidly.
come on. Come on.
And the funny thing about it is when you ask physicists about this, they take an approach that probably neither of us would take. They go positivist and scientific anti-realist, and they actually go down a Kantian approach to say, we don't really know what's going on here. We're just using it to get predictions, and say that this correlates with reality is stupid. And so they go down to an approach of saying, basically treat the wave function as the Kantian noumenon, okay, which is even more insane than. And you press them on this, and this is eventually what you get to.
Listen, what are you? All right.
I'm not a Kantian. I'm not a Kantian, which I think
I know
you like that.
Kantian. I know you're a Kantian. Don't even try.
But
No, okay. I don't.
you are a
think-
Platonist.
The big thing you have a problem with is that
We all know he's a Platonist.
a Platonist, right? But a Kantian, what you were saying is that you can't know reality from observation, right? I'm saying you can know reality from observation, but reality is not quite what we think it is. We can figure it. Well, that means we can figure it out from observation.
That's a
We have to be very.
We cannot know reality from observation alone.
Yes.
We have to use reason to connect the dots.
Correct, and that's where I used the reason of the but that was the other argument, the non-physics
Wait,
argument was we have
I just cannot let it go. I just have to. Johann Ratz, you'll have to give me just a second. Super Finn guy, let's talk about that for a second. You said we cannot. Go ahead and elaborate on that, because what I want to, I'll just give you my running hypothesis. The only thing we have is the information from our five senses and absolutely nothing else. Then we have this thing called induction, where we sort of make educated guesses, and those educated guesses are brilliant, and they tell us about the nature of reality, like Benjamin Franklin finding out about electricity and lightning and so on. Those are brilliant. But at the end of the day, all we have is the five senses. Talk to me.
Yeah, well, empiricism, I think they are inseparable. You have to have observation and reason. You know, for example, I'm against empiricism. Because I think empiricism is anti-conceptual.
You've got to have. Wait. Give me some evidence.
Like for well, what I'm saying. What I'm saying is that if you just observe something is not enough. You have to put it in context. In context, you have to see how it relates to everything else. What it is. You have to qualify it.
What is a context?
A context?
What is a context?
Well, a context is what matters in a situation. It's a situation that a certain piece of information is, right?
All right. So you want me to take my observation and put it in the context. That's what you said. That was your sentence.
Yeah, exactly. You take what you perceive.
The context is what matters in the area. How do you know what matters?
Well, from the
Perception.
You take what you perceive.
So far you haven't gotten away from perception, but keep going. See if you can get away from perception.
Okay. Well, you perceive things, right?
And they're in the context.
And yeah, exactly. They have a context.
Yeah.
You see how those things relate to each other.
Yeah.
You know? and then you form your. Yeah, I agree. But you have to identify those relationships. Yeah. But the thing is that you have to identify those relationships because a dog.
Let's do an identification of a relationship. Let's do that, because I won't even you don't have to go any further.
Okay.
Let's do an identification of relationship. Let's do something. Let's go ahead.
Okay. For example, take the example of a dog. A dog, I've heard that dogs only see in black and white, but let's suppose that a dog sees in color, right? It sees and it hears exactly what we do, right? What we are capable of. But
why do we talk about a dog? I don't know about a dog. Let's say
I'll go on. Okay, it's just a point. Well, hold on. I'll get to the point. The dogs have the same sense, the same sensation as we do, right? It can taste.
I don't know.
Yeah, but we are able to identify things that is based on the mind, because without the mind we cannot make those connections. We cannot see the relationships without some processing, some higher abstraction, you know. So we do need the mind.
Wait. No, no. You know, you skipped something.
Okay. Well, okay. What I'm saying is that we have the perceptions, right? But to make sense out of the perception, you have to have a brain. You have to see, you know, you have to relate things together, you know, and sometimes, for example, you can deduce things without seeing them. Like, for example, we can deduce that there are, say, electromagnetic waves. We don't see them, but through our observations, we can, you know, put things together and realize that there are waves, that there are,
All right. That's going a little bit abroad to be able to prove your point concretely. I'm asking you if you can. We've gone quite a ways. I have to say we can get back to rots and whatever we were talking about in a second. But I was asking you to say if there's anything besides the five senses that we have, and I don't think.
Well, we have the.
Is it?
No, I think, well, we have the five senses and we have our brain, because without our brain we cannot put things together.
Well, okay, I'll give you Peikoff's treatment of induction. Induction being, okay, let's say measurement omission. Ayn Rand. You've done Ito. You do the Ito.
What's that?
Introduction to objectivist epistemology. Have you?
I've read just part of it, not all of it.
Have you read? Let's see. Have you read Peikoff's The Philosophy of Ayn Rand?
Yeah, it was a long time ago, so my memory isn't so. But I know the main points.
Fountainhead or Atlas Shrugged?
Those I haven't read. I've read just the non-fiction works of Ayn Rand, like the Virtue of Selfishness, you know, the I Know an Ideal, things like that. Yeah.
Well, let me just, okay, in public right here and now, let me just say, we need to get together and have dinner. When can you come down to Connecticut, or when can I come up to Massachusetts? Because I live in Connecticut right now. So.
Oh, okay. Well,
No, here, let me just interject. Mr. Hornbuckle, who may or may not join us, has joined us in these chats, lives in New York. We should do like an objectivist Boston, Connecticut, New York triumvirate.
Yeah, that'll be cool. Yeah.
Yeah, we'll go to a strip club in Rhode Island.
Yeah. That'll be interesting. Yeah.
All right, so that's a seed. Remind me tomorrow, because you've seen what's happened tonight with me. So just tell me tomorrow what's happened.
Yeah. Okay. Yeah, that'll be very cool, because I'm your big fan, and it would be like an honor to meet you in person.
Yeah, well, I'm actually. This is actually a long-term plot by me to get to know you, because I'm schizophrenic and I want to stab you. So.
well. So you think that the sense perception needs to have the mind. Without the mind, you know, you cannot see some things. You have to use the mind to get to a higher conception.
Now,
for example, take the example of when, for example, ages they use epicycles to describe, you know, the planets and stars in the skies, right?
Right.
They were following you know, their perception, and because of that perception, they for example thought that it was the sun that moved. They thought that this planet is moving zigzags and stuff. But for you to see that it's not the sun that is moving, that is actually the Earth that is moving, that requires some, you know, some higher abstraction.
Well, you say perception, but can I just interject real quick, because you say perception, they going by strict perception, they actually had a lot of information that didn't say that the Earth was the center. It didn't say that the sun was moving. For example, when you look over the horizon of the ocean, you can see the mast of a ship, and then later you see the sail of the ship, and then later you see the bit of the sail at the bottom, and then later on you see the ship itself. So they knew that there was something going on with the curve. Also, they knew they could tell that the sun had gone down earlier over there, and the moon came up over yonder, and that the shadow of the Earth had interrupted the shine from the sun. They knew the Earth was round for lots of reasons through visual, actual contact of their senses. The problem was conception. The problem was to conceive in their mind.
Yeah, exactly. Yeah. So that is all I'm saying, is that you need the brain to connect the dots.
Yeah.
That's what I'm saying.
Yes. Okay. Well,
Like, that's why I brought up the dog, because the dog has the same sense perception that we have, but it cannot connect the dots as we do.
Yeah.
So that's what I'm saying. Yeah.
Well, and so people throughout history saw things with their eyes and didn't connect them with their brain.
Yeah.
Thought we lived on a flat world, even though they saw coming over a horizon.
Yeah, some of the clues. Yeah.
Yeah, they saw lots of clues. So tons of clues, including the shape of the Earth on the moon when the sun.
Yeah.
All kinds of things they saw and couldn't conceive it.
Yeah.
So the only thing we have is what we see from reality, and we can introspect from that and only from that.
Yeah. I agree. Yeah.
All right, so we're on the same page there. Good deal. Okay. Mr. Ratz, I don't know if you're still available and with us. Are you still?
He's muted.
He is muted. Okay, good deal. Listen, I gotta grab a beer. Go ahead and speak. If either of you have anything to say, speak now.
Where were we on before? I don't even know.
We were on politics. I think I said Trump was going to win, and you said Hillary is better.
That was beforehand. No, oh, hell no.
Go ahead.
Yeah.
But Katrina Pearson works for Fox News, right? She's at. We were talking about this, and she raised the possibility of making quantum promoting quantum idealism on Fox News when she did the Trump campaign.
Really? Yeah.
Yeah.
But I think that quantum idealism is a step back, because
a step forward. It explains more data than
I don't think so. I think it mystifies science and physics, because anyone can come. Like, if you look on the internet, there are a lot of outlandish theories about God, about spirits, about ghosts, and they all try to rationalize it with quantum mechanics.
Right, but the difference here
it's so mystified.
You'd have quote-unquote God, but the thing is that God would no longer be in the realm of some. When you use the word mystical, what do you mean by what does that, or mystify?
It's something that we don't have a conception, a true conception.
Right, but the difference here is that it would be God, unquote, right? Because you have an actual mind, but it would not be a mind. It would not be a thing that would be outside of our ability to reason or study it. It's an actual scientific model that we can know in precise detail. We can use to make predictions. We can model it. We can put exact mathematics on it. There's nothing mysterious about it.
No, it's woo-woo. Dan Dennett calls it woo-woo.
But
Dan Dennett's an idiot who doesn't believe in qualia or his own mind.
Freaking brilliant. Are you kidding me? We'll do a Dan Dennett.
He doesn't believe in qualia. I know. I read his philosophy of mind. He's insane.
We will do a Dan Dennett hangout, and you will not show up because you'll be frightened.
No, I can refute his stuff. It's actually.
Go ahead. Oh, that's it.
He's an eliminativist. He's an eliminativist.
Gentlemen, I hereby announce that Dan Dennett.
He's an eliminative materialist.
Will fail.
He's an eliminative materialist. I mean, at least you could do functionalism or emergentism. That makes more sense.
No, go ahead. You have a week to prepare. You have a week to prepare.
All right. You do know
Well-
he's an element materialist, right?
All right, let's avoid Dan Dennett from here on out because you have 1 week to prepare, and
I can dig up all kinds of quotes of him saying completely insane things when it comes to consciousness.
Go ahead, anything but Dan Dennett.
Like for example, when you talk about consciousness,
Same with Marvin
you
Minsky.
you have to define it first. You can't just say that something.
Right, I know, but they're saying things that are flat out wrong, right? Like, it was a clip, I forget where I found this, but Marvin Minsky actually said that we don't even have consciousness. You think we have consciousness, but we don't. Like, I mean, as objectivists, you guys have a problem with that, right?
I'm conscious
And
of myself.
Exactly. One of the axioms of objectivism is that consciousness exists. Am I right?
Yeah, well, that's an axiom. That's an axiom of objectivism is ridiculous. It's an axiom.
Right. Well, what I'm saying is
that's what we
the
all
people
can
in
do.
Dan Dennett's camp deny that in varying degrees. Sometimes they deny it flat out.
When you open your mouth and talk, you accept it.
Oh, I know you do. But what I'm saying is they don't. They're insane. Okay. They're actually walking pea zombies that deny their own consciousness.
All right. Well, then let's talk about somebody else.
All right. That's what I was getting at when, I accept that Dan Dennett is a brilliant guy, but he's also...
Well, shall I tell you about Lenin's theory of labor? It's quite boring and it's wrong.
Right. Well, eliminativism is wrong because it denies consciousness. But there even is consciousness.
Well, there's a high bar here to pass, Mr. Ratz, because I do have objectivists watching, and they do wonder why I talk to you, because you're full of shit.
Well, at least I don't deny consciousness. Would you agree with that? I mean, Daniel, the eliminativists are full of it more. Right?
Hey,
I'm full of it. At least I don't deny my own consciousness.
Yes, you did. You just opened your mouth.
Yeah, you just
No.
said
I was saying that the eliminativists deny consciousness. I accept that consciousness exists, okay?
But
The
you also
eliminativists
said
deny
that
it.
we think that we have consciousness, but we
But
really
that
don't.
was Marvin Minsky. He's an eliminativist. I was using that as an example of someone that was insane, saying that he thinks that he has, we don't have consciousness. We just think we don't have consciousness. We just think we do. Okay.
Yeah,
That's
because that's a
not my
contradiction.
quote. I know it's a contradiction. Okay. I was just pointing that out. Okay. That wasn't my quote. That was Marvin Minsky's quote, who I think is completely insane when it comes to consciousness.
Well, okay.
And I think you would agree that he is completely insane when it comes to consciousness, denying your own consciousness, right?
Well, then what point would there be in doing that, and why would you? Okay. So let's say he says that's true. Let's say we subscribe to his theory. Where does that lead? What implications does that?
It's an immediate contradiction, is what it is.
Okay, the reason that you subscribe to a theory and believe something and is because it has some frickin' implication of some kind, right?
Well, he wants there just to be matter. It's called eliminative materialism, and they see consciousness as a problem.
So for you, a theory is something that you just fucking whatever.
I'm describing their motivations for adopting this. Okay.
For me, a theory is marching orders.
Right. They're picking the theory and then trying to shoehorn in the data without any reasons for it to make it fit a predetermined metaphysics that they want.
Perhaps you should absorb a little more closely what I say. For me, a theory is marching orders. In other words, if it's that true that we can talk about it in this level and we can test it, then we need to send troops out. It doesn't troops in the sense of money or effort or time, regardless of what the implications of it are. If a theory is true, it doesn't matter what the seeming implications are, and that's marching orders for me. For you, it just means let's just fucking write an essay or something. I don't know what you think a theory is. What's a fucking theory for you? It's nothing.
Well, actually, a scientific theory in the scientific sense is a model that has been tested over time to the point where it's got a solid body of evidence behind it and has.
Yeah, but the thing is that quantum idealism, doesn't have evidence.
Actually, it does. If you look at Hoffman's model, which I actually emailed him I'll read you what he said, okay?
Come on. Gotta do better.
Hold on. His theory is extremely powerful and actually explains. You know, when you have okay, first I'll read it and then I'll show you. All right. Okay. Through Dr. Hoffman, I've been seeing work on interface theory, where you describe spacetime as emerging from conscious agents, and realize this may converge with other work. Specifically,
Super Fin Guy wins on that point. I think Super Fin Guy wins on that point.
On what point? On what point? All right. It explains, for example, why quantum spins are the way that they are, so that you can, you know, go around them. When you go around a particle, you go 360 degrees around it, and you end up on the other, you know, right back where you started. But with quantum spin, you have this peculiar problem where you have to go 720 degrees around it, right? Which makes no sense from a classical.
I already got that. I've got notes.
It does from a mathematical perspective.
Well, no, that's the thing, is that Hoffman's, that mathematical perspective that you're describing, it doesn't just, I mean, it describes it in quantum mechanics, but doesn't explain it, okay?
Okay.
Hoffman's model
I've got accidental cascading mathematics that can do that, though. I already have that.
Right, but this is not an accident. His theory is not an accident. It starts from conscious agents and builds itself up.
Excuse me, it fits into a nice little cubbyhole of the universe where there are things surrounding it that don't make sense, and there are things over the side that don't make sense, but there it is. And so you have a discrete mathematical phenomenon, if you want to look at it in information theory. You have an entity which has its own, is discrete from its surroundings, and it can cascade from accidental rules above it. It does not need some sort of, you cannot draw inferences of its metaphysical nature.
Okay, if there is a model that treats laws as accidents from one step to the next, and there's another model that says that they're not accidents.
It's a lower phenomenon. It cascades from other phenomenon.
What I'm saying is, if you have, you're going with Wolfram's idea that there are accidental laws at some point.
It results from other things. It's a result.
What is the result?
Whatever you want to talk about. Everything you want to talk about
something is, you know, fundamental and is the reason behind things that are not.
You cannot talk about anything that's not a result.
Not a result? You have the experimental data.
That's the problem, is you want to talk about things that are not results. I only want to talk about
results. These have results. I was bringing the results up to the time.
I didn't say that. I said it is a result.
What is a result?
I will only talk about a thing that just is the result. You don't allow that. You won't do that.
But you have to have if you want to understand what's going on, I mean, you have a...
See? I rest my case. QED.
Well, okay, you can do it a different way. You can say there are certain things that cannot be true if X is true, and so therefore, if this experiment turns out a way, then it's not just a matter of it being a theory behind it. This is actually what this evidence means.
Yeah. Okay. Oh well. Go ahead.
All right. So the point is that you can actually do this with the whole notion of the universe being a quantum computer, not a theory. You can have it as a result. Okay.
I can do what? I can do what?
You can treat this as a result. The whole thing with non-realism, that you can take the theory out of that completely, and then just do the Leggett inequality experiment and say that's an actual result. Okay. You can do the same thing with the Bell inequality experiment. You can do the same thing with the Wheeler-DeWitt equation experiment, and you could do the same thing with the mechanism behind anesthesia, which disrupts quantum entanglement in the brain.
Well, Super Fin Guy, do you want to chime in on anything that I have said, or
well, the examples that he's pointing out that the reality is a result of, like for example the Bell inequalities, those can be explained by more cogent theories, by more probable theories, not by
which is not Bohmian, for example.
Excuse me?
Which, for example, would not be a Bohmian model, which violates relativity and includes additional ad hoc mechanisms to explain things that there's nothing. They don't actually explain anything. It's an additional mechanism to try and force fit
No,
a
no.
metaphysical model.
Like for example, like with the pilot wave, we see that that particles, their path behave in a wave interference manner. So
Right.
that's not an ad hoc. Those are things that we can observe. What it is an ad
Those
hoc,
things
saying
are all.
that there's a quantum computer behind it,
No,
right?
the pilot wave. We don't need the quantum computer one is the more parsimonious one. The pilot wave, you have additional stuff there, additional hidden variables, and additional tachyon signals, and so on.
No, not
don't-
really, because you just need to have a pilot wave. You just need electromagnetic forces. You just need
The
what you
pilot
already have.
pilot wave doesn't. No, because those that pilot wave, even if it were to exist, which has additional problems with hiding heat capacities, the very notion there being a pilot wave there to begin with, rather than simply a program which doesn't need to have all the minute variables that a pilot wave would have.
No, but the thing is that you haven't detected the program. Like
Well,
and as far as we know,
let me give
the
you an
wave
example.
must be real.
I'm going to give you a direct example. You're not going to like this. I'm going to give you a direct
Okay.
example of the universe being information. Okay, actually, we're actually seeing not just as a theory or anything. We're actually seeing the bits of information themselves, minus the matter. Okay. It's called the quantum Cheshire cat. You guys heard of this experiment? It's actually pretty new.
Cheshire cat? Oh, I know about that.
The Cheshire cat, not the Schrodinger's cat, the Cheshire cat.
Oh, never heard of that.
Okay, what they did is they were able to split off one of the particle's properties from the particle itself. They had the spin floating over here and the rest of the particle over there.
Ladies and gentlemen, I just have to interject for just a second and say that this experiment was done within reality. Go ahead.
Yes.
Yeah,
So they sort of like detected the particle at one position and had its spin at another.
Yes.
And its properties separated from.
like a spin. A spin is sort of like an action of the particle. So so what was the spin that they detected?
Well, its properties were separated from
momentum. And it wasn't limited to spin. They can do this with any of the particle's properties, and they can actually do it such that you can do it simultaneously, where you take the particle and you disintegrate it into pure properties.
At best, that is a provement for the ether. That proves the ether.
Yeah, exactly. Yeah.
No, that proves that they're actually seeing the information, the naked green matrix code.
Like the thing is that they are seeing information, but that information is what we can observe of something. It's not.
Right, well, where's the something though? Where is the something? Something has a place, right?
Yeah, exactly.
And is the something over on this detector over here, which has measuring the spin, or is it over on the thing with the mass over there, or is it with the electric charge, which is
Like
beam
for
down?
example,
The point is that you can't talk about a thing in that case because there is no thing to have there. It's all a thing has a discrete location, but that thing there is no thing there. It's a bunch of properties that are dissociated from each other.
But the thing is that a wave it's not localized. For example, you can drop a rock in a pond, and it will have effects all over the place.
Yeah, but you would agree that the whole point is that the electron itself is a particle. Even if you adopt a pilot wave and you say that the electron is riding some pilot wave, the electron itself is going to have these properties, right?
No, wait.
Yeah, like the electron is not sort of riding a wave coming from someplace else. It's riding its own wave, and the wave, for example, of the proton, and that forms a wave.
It's got a wave with it, but the wave is not the particle. Okay, I mean, if you go the traditional quantum mechanics route, the wave is the particle. If you go the Bohmian route, the pilot wave route, the particle has its own wave, but it's not itself the wave, right? There's a distinction between the wave and the particle.
Well, sort of like you could consider the particle as a focus, right? Like where there's like a spin.
A resonance.
Okay, but then now you're going back down. Now you're going back down to the probability wave thing, though.
Yeah, exactly. Like for example, if you know this
traditional QM.
There's only energy. There's only energy.
And this theory, it shows, for example, in pictures of atoms, you can see that there's sort of like a pinch effect in the middle, like the wave function doesn't exactly just go around. There's like a sort of like intersection in the middle, just like you know, a drop inside another drop, you know. So you can
You're talking
see
about
that
like
there's like a pinch effect there.
Oh
Yes,
yeah,
say
there's a
again?
probability wave. I mean, you see that. I mean, that's predicted with regular quantum mechanics as well, though.
Yeah, but that wave is it's sort of like computed as a statistical wave. It's not seen as a real wave. Like the pilot wave shows that it's actually a wave. You know, you
Right. What
cannot
I'm getting at is it's
you
both a statistical wave and it's a real wave. It has the effects of it's not
What
the
evidence
wave function.
is the real wave, though? What evidence is there that it's a real wave?
Well, it's not a
like
wave in the sense of it being a physical wave, but
you
it's
can
a
you can see that it's a real
mathematically
wave
it's a
because you can see that its effects, and you can reproduce it in the lab with walking droplets. You
So it is
can,
a real wave.
yes, it's a real wave. It's the wave of the electron and the wave of the protons or other particles involved that
right.
form that wave function.
But
If you read
that's
De
standard
Broglie,
QM. That work that's the same on standard QM as well, though. What I'm getting
say
at.
again.
That's standard QM treats the way. I mean, if you take a scientific realist approach to QM, and
Yeah.
not just an anti-realist approach, they will treat the wave function as a real thing as well. Okay,
Oh, great.
even without pilot wave. Okay, that's just
Mhm.
standard. That's the wave particle duality
So,
in
Yes.
QM.
so do I go too far when I say that energy, that matter, is a resonance of energy?
I think there's some validity to that. I mean, E equals mc squared already. That doesn't give us any new information, though. It's just there's
Well, let's say
matter energy equivalence.
I'm an ancient Greek, and I'm a freak in ancient Greece, and I say that all matter is energy resonating in a certain way.
I think there's
Yeah,
validity to that.
I think that
You know what that
that
sounds
the particles are standing waves, you know,
You know what that
Yeah.
sounds
and
like?
standing waves oscillate, you know.
You're gonna hate this.
So you could say that particles are packets of energy, you know,
We
Can
packets
can't
you
of the
just describe
electromagnetic.
find matter anywhere, do
Robert, what
we?
you
We
just
only find
described
energy. We only
sounds
Say-
like superstring theory.
don't go to string
Oh,
theory.
yeah. String theory, it's like even worse than.
I know. I have problems with string theory too. I think it's gotten a little too out of control. But what I'm saying is what you just described sounds suspiciously like string theory.
No,
But it's not. But
I
it's
don't
not.
have, well, come on,
It's the pilot wave theory.
pilot wave theory. Is that Bohm? What do you think?
That's the
Bohm.
Broglie.
It's Bohm, yes.
That's the Broglie.
All right,
Bohm.
yeah. Bohm's excellent. Bohm's brilliant. I don't know.
Well, he was brilliant at the time, but there's
Oh, he's brilliant at the time. Now we've deduced that God runs everything, so Bohm's not brilliant anymore, right?
you know what he thought the super implicate order was, right?
We can do what?
You know what Bohm thought the super implicate order was?
What would? Well, okay, go ahead.
He was asked this question, and he said it's God.
That's his problem.
Now, you want to hear something more hilarious, actually. Now, this is something I don't go. He had a bent spoon in his pocket from Uri Geller that he believed was bent using telekinesis, which he thought he could explain with his model.
I
And
don't.
then he also was, what's his name? That Hindu guru. He had him as his spiritual advisor, I think. So,
Yeah.
if you want to avoid, and he was using his model to try and prove this. So now, irony in this is you're going to Bohm to try and get away from, this scientific model I have, and you're going to Bohm, and you're ironically running into the exact
Oh,
same
come
thing
on.
in a different
Your
approach.
model's not scientific. Come on. Your
It's
model.
scientific. It's scientific.
That's a perversion of science if you call that
Okay. I'll tell you what, Rats.
Mhm.
Like, if your theory is valid, so
Mhm.
make a prediction that I cannot make, for example, with the pilot wave theory. So that will give
For
it.
example, you'll find there's a phenomenon called gamma synchrony in your brain. Okay, there are proteins in the back and the front that are entangled with one another. Okay, and when you disrupt that entanglement, your consciousness shuts off. And you're not going to get that out of the Bohmian model because the pilot model, because the pilot model doesn't even apply consciousness at that level.
Your consciousness shuts off.
Consciousness, but the thing is
it's how
that
anesthesia works.
what are you calling consciousness?
Yeah, that's
Well, it's when someone is awake, in the hospital, right, and they have the nurse comes by, the attendant comes by with the thing that says breathe in this, and you breathe. Consciousness is what shuts off just after a couple seconds after you breathe
well,
Yeah, but for example,
I don't know about that.
okay. So you're calling consciousness awareness because an ant is awake, and we can't say that an ant has a consciousness. It has introspection. We cannot say that. But if you're talking about awareness, yeah, like there are evidence that the brain is controlled by electromagnetic states. So if you can shut that with a magnetic field, for example, you can shut that off. Or
It's not using a magnetic
that.
field; it's using a chemical to disrupt to cause decoherence in the quantum.
Well, yeah. Well. For example, a substance. Remember that chemistry is basically electromagnetism.
Well, I suppose it's true. You can go, yeah, okay. All right, so you can have well, of course, that really doesn't give us anything new because all interactions biologically ultimately reduce to electromagnetism, and so electromagnetism, as we know, is described by quantum mechanics through the theory of quantum electrodynamics.
Yeah, exactly. So your example just shows that the substance can interact with the brain in a certain way that will shut it off, but it doesn't prove like the entanglement that you just pointed out.
No, the reason is because all the other functions of the brain are still processing during anesthesia, and it's very specific. Only the gamma synchrony shuts off. And so whatever the gamma, and that is the entanglement on both sides of the brain. So whatever the consciousness is, it's not located in any of the functions that are still going when the person is, passed out on the operating table, because otherwise he'd be conscious. So it's located only in the quantum entangled information.
I just don't.
Well, there like for example,
well,
there
you
could
can't
be like
buy it if you want, but then for that same token,
basically maybe I would say that by doing that you collapse a certain state of the wave functions going on in the brain. So that could be the pilot wave solution for that.
Can you do better than that, Rats? Because that's awful. I mean,
that's the consciousness. Okay, I suppose you could tie consciousness to that and just have it be you could have a realistic model of quantum mechanics and supposedly tie consciousness somehow with that.
Well, okay.
All right,
Yeah,
so let's put that aside. What you can't explain is quantum non-realism. Experiments proving quantum non-realism.
No, come on. Return to the original point. What's your original point you're trying to?
He wants me to give me an experiment that you can't prove with the pilot wave model does not prove. It's not compatible with.
Yeah.
I just showed you that.
Bell inequality experiments are not compatible with it, and non-realism is not.
Let me just interject for a second. Superfin guy, you talk for a second, then we'll let Rats try again, or if we can. We'll see what happens.
So Bell and Leggett.
No, let me let Superfin guy talk for just a second first.
All right.
Yeah, well, yeah, like as I was saying, the example that he came up with, I just showed him that it could be explained by the pilot wave theory.
The entanglement.
Yes, the entanglement could
How do you get faster than light signals?
Excuse me?
How do you get faster than light signals?
Now,
like for example, with a scalar wave, for example.
The scalar wave doesn't transmit information.
now I did.
It does.
No, it doesn't.
Like for example.
A phase wave, okay. A phase wave does not transmit. Phase velocity does not transmit information.
It's not phase velocity. It's just a scalar wave.
Group velocity doesn't transmit.
It's sort of like a sound wave. Take a sound wave, for example.
Okay. That would mean. Okay, there's a problem with that. If that's true, then you should be able to use it. Basically, what you suggest is that there's time travel at this quantum scale. Okay.
Yeah, maybe yes, of course.
Backwards in time travel.
There's an interconnection of nodes that goes back to before space and time, or the nature of what they are now, which interconnects things in a way that, okay, but time travel is a bit strange for you to say, because it's a concept that only applies to the universe as it is now, and these nodes go back to an earlier time.
Okay, so
Yeah,
you're going to posit time traveling tachyon particles to.
No,
Yeah,
you
yeah,
are
like
positing
that.
that.
No, that follows. If you have FDL signals, you have backwards in time travel.
I don't need any of
Well,
this stuff.
like FTL speeds, they don't require backwards time travel, because
Yeah, they do.
I can disprove that. Like geometry, you could say that, but I would say that as the speed reaches infinity, it could go to another it could go to another dimension. For example, you say that when a ship goes at very high speeds near the speed of light, it gets more massive, right?
Mm-hmm.
It gets more massive, so it gets heavier, and the propellers cannot increase its velocity beyond a certain point.
Actually, something
But
worse
the thing,
happens.
but okay, let me finish just a bit.
All right.
As the ship gets more velocity, it gets more heavier, and so its fuel. So everything would be increased in mass in proportion. So it like the problem with mass getting with the ship getting too heavy, it's not really there, because everything increases in mass in proportional. So the ship would get heavier, but its propulsion would get
You're right.
stronger too.
That doesn't. I mean, that's fine with lower than light speeds that approach the speed of light. But we're talking about faster than light. Now,
Yeah,
really
at
fast.
one point, it will get
Really fast before we continue. I want to ask something very quick and get a response. You would agree that if there is imaginary numbers, like square root of -1 kind of thing, being applied to actual things in the real world, that there's something wrong with that you did something wrong, right? You made a misstep.
Really, everything show complex numbers and imaginary numbers has to exist in they have to exist in reality. And actually, there are calculations, for example, in quantum mechanics, that are not
Right,
possible without.
I know.
Yeah,
That's correct. That's correct. And it's useful mathematically, and it cancels out always whenever you have an actual observable, the imaginary number always cancels out, and you have it always comes back. And actually, it was when we took quantum mechanics, the professor said if you get imaginary numbers on your observable, you did something wrong.
Hey, well, guys, once again, I don't know if this is really cogent, but I have to point out that all of mathematics fits within Wolfram's universe, so that
Okay.
mathematics is like a corner of it, so that
If something is going into imaginary time, what would that correlate to in reality?
Imaginary time.
Yes.
For example, the angle in reality, for example, as you increase, for example, take for example when you calculate time dilation, or when you calculate the Lorentz
Right.
formula, right?
I'm looking at that formula right now, actually.
You see that what you have there is a complex situation.
It only becomes complex. It only becomes complex when you have faster than light speed. That's why I brought that up, by the way.
Yeah, but
With a faster than light speed, you'll have
the thing that
going to plus and minus imaginary time. It'll actually be going backwards in imaginary time, which is even weirder than going backwards in time.
well, the thing is that the main point is that those complex numbers, they describe real things in reality.
Right.
So,
Well, no, the thing is, that's the thing is they don't quite though. They cancel out. They're mathematical tools, and then when they're used,
they cancel out what
they obey the rules in such a way that they always abide by reality when they're done. But the thing is in quantum mechanics, which is the one place we use imaginary numbers in physics, they always cancel out when you end up getting an actual observable out. When you calculate expectation values out of your wave function for momentum or position or whatever, the imaginary component of the wave functions always disappear, and you end up with a precise, real valued momentum or velocity or position variable.
Yeah, well, yeah.
What would it mean to be going into I can imagine. I mean, time travel is one thing, right? I mean, like, it sounds sounds crazy, but you could you all seen Terminator and so on. You could imagine that at least, right?
Well, from a relativistic point of view, time travel is not it's not crazy. It's something.
Right. But what doesn't make sense is imaginary time, right? I can imagine looping a wormhole around such that you go back in time, but I don't know what it means to go into imaginary time.
Well, like, for example, you would say that imaginary time is going in the y-axis, for example, instead of time going in the x-axis. Is that what you're saying?
Well, that's the thing. That's what I'm asking. Is, I mean, we only have one axis of time, and we have different reference frames with different time, T1, T2. But those are always real in their own reference frames, and they're even real in the other reference frames. They're just, they're time dilated.
Well, I could give a crazy hypothetical that black holes have connections between other bits of this, but that doesn't affect our area. So
they would have like wormholes, for example.
Well, yeah, but the wormholes might all connect inside black holes, so it's not very interesting.
Right, that's correct. But then the question is, if you bring up wormholes, the very notion of wormholes or space bending or so on raises the curious question of if space can bend, right, which is supposed to be thought of as empty nothingness, space has properties, space is complex, which means space is emergent. Complex, simple things are not. Well, if something is complex, it's not fundamental.
Well, space is just a concept. Space is just a concept. It's not a thing.
Why is the concept bending in such a way that you can create Stargate portals to other planets and then ultimately back in time if you make one of the planets and go to a black hole?
Because space has the properties of something that has matter. It has Einstein said it that it's inconceivable to think about relativity without thinking of the ether, for example.
Okay, would time be a concept as well?
Yes, time is a concept. It's movement.
Okay. So now the question I have is, actually, with wormholes, for example, which are allowed under relativity, I create a wormhole. I have one Stargate here on Earth and a Stargate on Mars, and I just hop through my Stargate, and I'm 50 million miles away on Mars, on the surface of Mars, right? In just one step. And if that's actual space that I'm actually bending space, and it's causing real-world effects. This bent space is causing real-world effects so that I can transit from Earth to Mars. And likewise, if time is a concept, I can put one of those stargates near a black hole and time dilate it, and then I can't go back before the time machine was created, but my grandkids can go back and meet me as a young man or something, right?
Well, you're not necessarily bending space. We have some evidence that there's no space between that space. Entanglement is evidence that we can go without any...
Okay, but you're manipulating... When you create the wormhole, you're manipulating space.
No, there is no space. There's no space.
Right. What I'm getting at...
Well, now wait. Let's go back to the point I mentioned earlier, that everything is connected to the node that everything grew from. So we don't have to traverse any distance.
Everything connects from the node that grew from. But what I'm saying is,
distance is
on the one side.
It occurs only between the bubbles within the node. If we connect to the original node, there's no distance.
Right, but what you're describing now sounds like loop quantum gravity. You're talking about things outside of space that connect via nodes.
Loop quantum gravity sounds like what I'm talking about. You've got it backwards.
Well, that is the same exact language Fortini was using, was nodes and things being interconnected by networks.
Well, as soon as they come up with a theory that can be tested, then we can talk about that stuff.
Okay, well, what I was getting at, though, is On the one side, you guys were saying that, you know, time and space and time are just concepts, but now I can do things with space-time. Another thing you can do with space-time is get rid of the wormhole concept and bend it in a concave fashion such that it's like a half wormhole, and you can stitch that half wormhole to the space around, and now you created a warp drive. You know, it could be a warp drive, okay?
Oh my God! I was just trying to talk about reality a second ago, and now you're talking about warp drives. Super
Okay,
Fin guy, do you
what
have anything?
what I'm getting at is that, okay, either you have a couple of possibilities here. Either space and time are concepts, and they don't affect reality. Okay, either space and time are just concepts and they don't affect reality. They're not object things that affect reality.
Well, right.
Or
like
they
okay,
are object things and they affect reality. Or you go on the other approach and you say, yes, they are conceptual. There are concepts, and concepts have object reality, and therefore that's why they're affecting it. So you can go down the idealist route and you can say yes, they're concepts. Yes, they affect reality. Or you go down the realist route and you say,
well,
yes,
the thing is that a concept, just because it's a concept, doesn't mean that it doesn't have effects on reality. For example, I see concepts as relationships that we see in nature. For example, like space could be thought of as for example, as extension, as the density of a medium. You know, if you were to contract or dilate that medium, the space from A to point B would change. You know, because you would have less density or more density. So
right, but that doesn't explain why you could then end up, you know, creating you know, you've densified the medium between point A and point B, but that doesn't explain why you simply create a hole in the medium altogether, then end up at that hole with nothing intervening between it. The other end of that hole suddenly pops up on Mars or something.
Yeah, well, that will be easy to explain. For example, with the density model, if you will, like there would be like of potential there that would create, you know, a very high speeds. You know,
Well, that's the thing is the guy didn't have any speed at all. He just stepped one step through the Stargate and then landed up on Mars.
Well, I don't think that would be possible, but
well, that's what the physics says is possible, though. That's the point.
Well, that's what knuckles.
That's the physics
that's
been
debatable.
tested very. That's the same physics that's been tested very accurately when we have, you know, gravity waves and time dilation experiments and so on. Gravitational microlensing.
Time dilation is very possible. Gravity shows it. We have evidence for it. So, but we don't have evidence for that type of wormhole that you're talking about.
Right, I know. What I'm saying is that it automatically follows from the same theory, the same model that explains why the space bends and you can, you know, dilate time and so on. You can have another one, relativity of simultaneity, right? You know, you would think that two events happen at the exact same time, right?
They don't. They don't.
They don't happen at the exact same time. But as I say, there's separate events. From one frame, they don't happen at the same time. From another frame, they do happen at the same time, and it's actually been experimentally observed, right?
Yeah, exactly. It's a consequence of relativity.
Right. What I'm getting at though is that's actually causing real-world effects on, you know, what happened at what time.
Yeah.
It depends on your reference frame, on your motion relative to those events.
Sorry, officer, I was going so fast that relative to me, the red light was actually green at the moment that I sped through it, whereas everyone else saw it as red.
Okay, look.
Depends on your speed. It depends on your speed and on how the light waves.
I know. What I'm getting at though is that these are on the one side you treat space and time as concepts. But then when you have to combine this with relativity, you end up with these concepts
working, right?
You have this conundrum of concepts causing actual effects on reality.
Well,
but the thing is that concepts are abstractions of what we observe in reality. There are relationships.
Why are these abstractions and relationships causing actually bending in themselves? Why do they have ontological existence like we see in relativity?
They
Well,
don't.
because that's how
What
things
do they
behave.
do?
That's how
Right.
you
Well,
know,
no,
matter relate to each
for me,
other.
I don't have a problem with you calling them concepts and then saying that they, with relativity, because I'm going down the idealist approach, right? But it seems like you guys, if you're going to reject the idealist approach, you got this conundrum here where on the one side you're calling them concepts and relations, but on the other side they have actual ontic implications, which is only what you would expect if,
Well,
concepts do not have ontology according to you.
why do
But
they have to have some sort of Platonistic existence in order
They
to
don't require
have
that.
a
Yeah.
reality?
They just require how matter behaves. They just require the laws of nature. They don't require that they're like mystical or
the laws
behind
of
like
nature are
physics.
saying that space and time are ontic things.
They aren't things. They aren't things per se. No. Like for
And then
example,
that's
like
what
space.
relativity is treating them as ontic things.
No, they relativity.
And the experiments demonstrate that they're ontic things. You can bend space, you can distort time.
But time does not. You
You can
can't
bend
distort
space
time.
into time.
You can
Distort time.
you can speed up time. You
One
can
person's
speed up
space.
time.
Another cool thing that you can do with relativity is that when you're moving at close to the speed of light, one person's space is another person's time, and vice versa.
Oh,
No, I don't see what you're getting. I never heard of that concept.
that's fascinating.
It's one of the I forget which experiment it was, but it's one of those cool. And they've actually experimentally done actual experiments with that too. But it's before that, it's one of the things you can do with relativity. See it in all the relativity.
Okay, let me break down to you what I think what relativity time is. Time is motion relative to something else. Like you move at a certain speed, and something else moves at another. You have different times because your speed compares to it in a certain fashion. That's why you perceive something going faster or slower. For example, if a train is going by and you're running at the same speed, that train is at rest. But if it's slower, it's going in the opposite direction. If you run faster than it, if you run slower than it, then it's going on the opposite direction.
Right.
So yeah, so like time, it's a relationship between between motions. So that's why it's not a thing. It's a relationship of something else.
Right, but why are you able then to manipulate matter and energy and so on, so that you can make that relationship, bend it around, and actually bend it, go backwards in time?
Well,
what do you mean?
well, if you would go back in time,
Well, for example, you can
like
use cosmic strings. You can do that with cosmic strings. You can do that with wormholes. You can do that with curve singularities. A number of ways to do that. They all form ways you can use those relationships to bend the concept around, such that the concept causes a traveler that goes through it to end up when his grandparents were little children.
Okay. Rats, take the train example again. Say for example, like the train, you're running at the same speed as a train, right?
Mm-hmm.
So you're in the same reference frame. If you speed up and run faster than the train, then the train is going, for all intents and purposes, it's going backwards in time.
Right. Well, no, it's going backwards
and vice versa.
It's going backwards spatially. It's not going backwards in time necessarily.
If you put it in a time context, it's going backwards in time. Like yeah. In this case, we're talking about space. But if you're
for example,
talking about
at the Olympics, you have a runner, right, and you have some guy sitting on the sidelines with the clock or whatever, where you have the audience looking at the clock that's measuring when the runners are going to run past the finish line, and there's one runner behind, and then he catches up and then actually outraces the other runner. And the other runner is not going backwards in time all of a sudden. The clock keeps ticking, and there's...
No, yeah. That's a spatial perspective. But imagine that both runners are standing still, but one, like say the atoms of the one athlete is running faster than the other. Then you have one going faster in time and another going slower. So that is a way to visualize how it would apply to time.
I'm going faster and I'm going slower, well, for different references,
Yeah.
of course.
Yeah.
What happens when you go to general relativity then? You have, black holes bending space.
But the thing is that Einstein, the idea of black holes, it was someone else that came up with it. There was like a correction.
Oh, I know.
I remember from the top of
car, right?
Yeah.
But my point is that we see that. That's something that we see. I can give you a photograph of bent space. Let me get one for you.
No. Well, you don't see, for example, gravitational lensing at the center of galaxies, and at the center of galaxies, there's supposed to be like a super black hole, but you don't see gravitational lensing. So that's one of the things.
We can't really see into that. I mean, it's covered by stars usually, but here's an example of gravitational microlensing, probably due to, I'm going to guess it's dark matter. I couldn't imagine there's a black hole that big that would be in the way, but maybe there is. Maybe it's much closer to us or something. But there you go. You see the actual space bent around in such a way that it looks like the galaxy is. You can see the space bending between the galaxies and us.
Oh yeah, like for example, that kind of bending could be due to refraction, in space.
You're refracting space, yes, not in space. It's of space. The space itself is refracting.
No, well, it could be caused by plasma, for example. Like, for example, in my case, I subscribe to the electric universe, and that explains it much better. And according,
it fits general relativity exactly. I mean, it doesn't add anything new. There's no electric fields that deep in space.
There are
these are millions of miles. There's millions of miles, light years between these galaxies. Okay.
If you map the magnetic field from the galaxy, you can see that field permeates the whole of the galaxy.
You understand a magnetic field that a magnetic field.
And you can see Berkeley currents all over.
You know what happens when you have you know what happens when you have a too strong magnetic field in an MRI? I mean, some of these not in an MRI like in the conventional, but like in some of these laboratories where they have very strong magnetic fields. Okay.
Yes, you have a deflection.
They can shear apart atoms. Okay.
Yes, sure. You have a deflection of the.
Yeah, you can't have people near them because it'll actually cause damage to the person at a cellular level. Okay. These magnetic fields are that strong. Okay. Now.
Yes, but
the point is that
yeah, go ahead.
A magnetic field that's strong that can do that. Bend the space of entire galaxies like that. You can see that in between. If you had galaxies with magnetic fields like that, there would be no. I mean, there might be clusters of plasma, but there's not going to be any solid matter there.
Well, like for example, it's so relative. I mean, like for example, like the sun, the atmosphere of the sun extends to extends far out into the solar system. There's a field there. There are currents there. We don't feel it because we are at that level.
Right, but this is at a level that's even much farther out. I mean, that's only we're 93 million miles from our sun, but this is not just 93 million miles. This is 93 million light years.
Yes, but the thing is that we can observe Berkeley currents we can observe what at NASA they called electron ropes. We can observe real current, electric current in space. We can observe them. Like,
where have they done this? What I have never heard of this.
well, you can go to the Thunderbolts YouTube channel. There you can find some references there. You can find some observations of the electric field of the galaxy. Actually, you could go to a NASA website and you can find the electric field of the galaxy. You can actually map it.
It's not going to cause that much force. It's not going to bend light though. Not like
Right.
that.
It's not. No. Yeah, exactly. It's not that the magnetic field itself is bending light. I'm saying that the plasma that the light goes through that causes.
There's no plasma. This is interstellar space.
There is plasma.
The plasma would be the size of whole galaxies.
Like for example, the sun has been proven to be plasmoid. The galaxy, it shows like in the lab, like with plasmoids forming in the lab, we can see that they have the same properties and characteristics and even shapes and morphology than galaxies and stars. So we can actually observe these things. We can see them.
Right,
and
but
we can replicate it.
Plasma creates a huge amount of light. Wouldn't you agree?
Well, there's a plasma in dark mode as well. You have like really bright plasma like lightning, and you have dark mode plasma.
It's going to give off radiation though.
It does. It gives off the radiation, X-rays, infrared.
There's no radiation where we see these gravitational microlensing things going on.
They detect infrared. They detect X-rays from deep space. They detect X-rays.
Yeah, but not
from even stars.
They get those from quasars and pulsars and so on, but they don't get those from the gravitational microlensing. I mean, they get it from the galaxies beyond them, and they can aim them at the galaxies and see that definitely is coming from the galaxy, but it's not from the gravitational microlensing that you see in the space intervening space.
Like the intervening space has a lot of plasma in dark modes that can cause that refraction. Yeah, but I'm not saying you should take my word for it.
Right, I know. What I'm getting at is it seems like it's. I mean, if this was like maybe around a star in a galaxy, and there was some faint. No, it's a question of plasma of what, right? I mean, when you have plasmas, they give off, light bands of whatever plasma it is of. Like, it's a hydrogen plasma, which mostly, it's mostly hydrogen. You start to see,
most
of red light and orange light and so on. And you don't see that. You don't see anything, any traces of spectral lines or anything like that. It's empty space.
Well, I have to disagree with that. There are spectral lines of plasma in
space. Yes,
yes.
You do see spectral lines in space. Yes, coming from objects, but when you pointed out a place with the gravitational microlensing, you see it from the galaxies behind, but you don't see any.
Any spectral lines coming from interstellar dust, so-called dust. I would call them plasma. I think they have observed that. I'm not sure.
Well, you see what I'm saying here is when I'm looking at this picture, it seems very obvious to me that I'm looking at bent space, right? And we'll look at the picture. It's bent space. I don't see why you'd go the plasma route when you have to explain where the spectral lines are. You have to explain, when we're not seeing it, how it ended up in the interstellar space with there's no evidence of anything in between.
There are you can it's been electrons, protons, ions and stuff have all been detected in physics.
Yeah, firstly, they're detected at a rate of, I think, what was it, interstellar space was like, I forget exactly what the density was. It was something really tiny, like a single atom for every
No, like
9
not
cubic
really.
meters or something like that.
No. I think it's way more than that.
No, it's not. I remember this. It's really sparse out there. It's
Like for
there's
example,
background radiation and
when
there's
Voyager got to the boundary of our solar
Oort cloud.
system, they were
The solar shock.
astounded.
That's the solar shock. That's to be expected.
Yeah, but the thing is that they found like the space teeming with particles.
I know that's because they ran into the solar shock, but we already knew that's
Uh,
wrong.
Yeah, but inside the solar system, like for example with the solar wind and stuff, they actually found plasma in dark mode, but plasma.
Where
So,
did they
yeah,
find this? In the solar system, right?
in the solar system, you can
You're
go, you
okay.
can look that up.
That's in the solar system, okay?
Uh-huh.
And I'm gonna guess they gave off spectral.
Take comets for example. It has been proven that comets are not dirty snowballs. They actually showed that there's no ice. There's very little ice on the surface of comets. Very little ice. Like you can.
We
you can
impacted
Google,
a comet. 1 second here. What was it? Where was that? We did this a couple of years ago. We blew part of a comet up. I can't remember the name of the probe, but I think they remember there being a lot of ice there.
No, they didn't. They sent a probe to one of those comets. I kind of forgot the name of the mission, but it caused a flash. It caused like a lightning phenomenon.
Yeah, I know that's because they impacted a small. They launched like a bomb basically at the back of the comet.
Well, they couldn't tell what caused the flash, and it was something that they didn't predict.
The point is
So,
that
like
we can tell what the chemical makeup of a comet is from looking at it from spectrum. We don't even need to we can go out and study if we want, but you can see that it's your cometary nuclei are composed of an amalgamation of rock, dust, water, ice.
Yeah, but the thing is that they did not find that.
That's what they have right here.
No ice. If you actually look at the data, the actual data,
the actual data is spectral.
That they found little ice on the surface of the.
What explains the spectral data then? I mean, we can see this without. We can just point our telescopes up there and then shine the telescope light through
Yeah, I'm talking about spectral data. Yeah, exactly.
Right, but the spectral data has told us that it's there's ice there. There's water there.
Very very little ice or none.
Look
it up.
I am looking it up, and that's what I'm finding right here.
Yeah.
I did miss out on a couple minutes of stuff, but are we talking about water ice in outer space?
Yeah,
exactly.
The composition of comets. The composition of comets.
What about Pluto? You heard about Pluto having extraordinarily large amounts of water ice?
Yeah.
Yeah, Pluto is covered in ice. It's an icy planet.
Oh, okay.
Yeah.
Makes sense.
I'm slightly out of step on what happened because I was out of the room for a minute, as you may have noticed.
Oh, by the way,
okay, yeah.
Not to change the topic, but have you guys heard of the Starshot program?
The what?
This is really cool. They have they're solar sails, okay, and they're they have like these little probes the size of microchips. They're very small. They made them really compact. They have cameras on them though, and little mini computers. And they're going to put them on specially engineered with the nanotechnology solar sails, which are designed to absorb laser light in large, very very high, very powerful laser light. Okay.
Mm-hmm.
As you know, photons give off momentum, right?
They give out?
They give off momentum. Light gives off
Yeah,
momentum.
okay,
Very small,
yeah,
easily,
yeah,
but when
sure.
you have, laser, they're like terawatt lasers, a whole arrays of terawatt lasers shining into space, aiming at these things, that produces a lot of momentum. And if the object you're shining it on is really super lightweight, like a tiny little computer chip with a, paper thin solar sail,
Mhm.
you can accelerate that thing really fast, right?
Well, can I just interject?
Or burn it. Yeah.
What or burn it? What they were trying to do was they were trying to figure out a way to get something to the next star within a reasonable time period.
Oh, okay. With cameras.
Within about 20
With a
years.
small spaceship like that, if a
Yeah.
spaceship weighed a hundredth of a gram, and they could put a 1 terawatt laser on it, they could get it there in 20 years. The problem is, like you said, burn it. You burn it up.
Well, that's why they're working on the nanotechnology to make it so that it can absorb the laser light. So
Yeah, that's a
they
best.
still have a couple of years left to go. They had a conference on this, and they're pretty certain they can do it. They just have to engineer for a couple more years, for like a decade or so, before they can get the specs up. They're close. They have stuff that gets it's. They said it's doable in the next 10, 15 years.
They put a man on the moon in 9 years.
Well.
Yeah.
It turns me off when the scientist says that something will be possible in 20 years, 15
No,
years.
it's closer.
They usually don't do it.
Let me see what it
Okay.
was.
I hope they can do it.
Yeah, me too.
But I
It was
think.
amazing.
Mm,
And especially because Kepler found
they
evidence that
they
there
would send
is
it to Alpha Centauri.
Yep, Kepler found that there is evidence of the Earth-like planet in Alpha Centauri within its habitable zone.
So yeah, I hope they can do it. But I think like the particles would be very hard to control. Or to,
Correct.
to stay in
Well,
the right direction.
the thing. Is there? Well, once you beam them in the right direction, they're going to stay in the right direction. But they're going to beam out there, and they're going to.
Well, the point is they're going to send a cloud of them, like many thousands.
Right, many thousands of them. So
Yeah.
some of them get messed up along the way, and then other
But
parts
maybe,
can.
maybe they could be deflected by magnetic waves. That could happen. There are a lot of things that could get in their way.
Well, here's what.
Especially in the interstellar, space.
Well, interstellar space. Once they get out to interstellar space, they're clean. But once they're
I don't think so. I think
in the solar system, they're
like
probably
from what we observe, from what we can observe from the data alone, the interstellar space is denser than what we have inside the solar system. Like the sun, the solar wind protects us from a lot of the cosmic rays that come from.
All right. Actual density of hydrogen is as it exists in interstellar space is on average 1 atom per cubic centimeter. In extremes, as low as 0.1 atom per cubic centimeter, and has been found in space. It's really tiny.
There's been observed a lot of ions.
It's practically hard vacuum out there. Okay.
Okay. Well, the data, I don't know where you got that, but from our observations, we can see that there's plasma out there.
I don't know where you get the notion of plasma in interstellar space. I mean, there's plasma.
Well, you can look it up. Like right now, I can.
I'm looking.
I can give you references from the top of my head right now.
Electrical.
And I'm kind of tired, but if you want later on, I can send you the references.
Okay. Interstellar medium. Here we go. Let's just see what we got here. Interstellar medium is matter that exists in space between the stars and galaxies. This includes gas, ionic. Okay. It's only telling me how much the density of it.
Okay.
Here we are. In all phases, which include plasma phase, the interstellar medium is extremely tenuous by terrestrial standards. In cool, dense regions of the ISM, matter is primarily in molecular form and reaches number densities of 10 to the 6 molecules per cubic centimeter. That's pretty still tiny. In hot regions, primarily ionized, density may be as low as 10 to the -4 ions per centimeter.
Well, I think that we can assume
Okay.
the interstellar medium's pretty rare, but it's also got pockets of.
Okay. I'll look up something. Hold on.
So if we're gonna send these fleets of stuff to the next star, the interstellar medium is gonna be like the thing between Mars and Earth, the asteroid belt. It's gonna be an obstacle, but not
Not a big one.
not.
I don't think there's going to be hardly. I mean, it's literally there's atoms it's bumping into out there. Is all it would be bumping into is single, little pockets of like microscopic atoms.
And wandering planets.
Wandering planets. Once you get out of the solar system, then yeah, that's not going to be a problem anymore, though.
You know, the planets are ejected as often as they're kept.
Well, they have talked about some planets wandering between stars, but they're very sparse in between.
Well, from what I understand of planetary interactions in early solar systems is that when planets interact with one another, one of them reaches ejection speed and the other slows down. And the clear implication of that is that there are as many wandering planets as there are captured, and even more, in fact, because a lot of the captured planets end up traveling in towards the sun, and the wandering planets don't. So the wandering planets probably outnumber captured planets by at least 1 to 1 plus C.
Hmm.
And that's fascinating, isn't it? It's very fascinating
At
because
least 1 to 1. So it'd be like, you know,
every planet there is
8, 9.
around a star, there's a planet wandering out with no star.
Okay, so in between here and Alpha Centauri, we might expect to find 15 to 20 planets.
How many?
15. You know, if Alpha Centauri is similar to our system, and we have, well, I don't like I grew up with Pluto being a planet, so I find a protest when people say it's not a planet. But you know, actually, but that standard we'd have 10 planets then, so the Sedna would have to be a planet then too. But so you'd have 10 planets in our solar system, 10 planets ejected, and then likewise, you know, assuming that Alpha Centauri, our solar system is average and Alpha Centauri's is average, then we have 10 planets out of Alpha Centauri, and we're from there too.
No, you're right. Given the magnitude of the space, it's absolutely infinitesimal.
Yeah. All right, I think I better get to bed here. So.
Listen, guys, this was a very great hangout. Lots of crazy physics.
Rats?
Yep.
Rats? Yeah, later on I'll send you the references. I'm kind of tired right now.
Oh, yeah, sure.
Yeah.
All right. All right.
Good times, good Saturday night, Sunday morning.
Yep.
Yeah, this was great. Yeah, very nice hangout.
Good times. All right, see y'all later. Good night.
See ya.
Good night. Yeah.